Hey, hey, we are live. We are back very quickly after your presentation there, Tony.
Hey,
I thought I'd open up an open panel in case anybody wants to join. So that's any globe earthers or flat earthers that want to join. If you want to send me a message on Skype, I'll add you immediately to the call. That way you can't say it's a circle jerk or anything like that. You know, we're here to talk to, and essentially, if you've got something to bring, if you've got something you want to discuss, then we're all ears. What about you, Tony? Are you ready for this?
Yeah.
Yeah. Let's see. I'll keep my Skype open. I know that Brenda said she wanted to join, so I'll add her to the call.
First question I'm going to ask her is, where does she think the horizon is on that thing? And if she doesn't answer that honestly, Ranty, just fucking kick her.
Right.
She's just here to tell lies.
Okay, I will do. Oh, we have a comment from Clutch, by the way, who wants me to pass this on to you. So, Clutch being right at the hand. So, he says it's very telling that you used the term polarized light and couldn't define it yourself, then went to Google, read the definition, and still didn't understand what it is, but still asserted that light is polarized. So, I'm just passing the message on.
I don't care what he says. He bullies women for no good reason, and I don't agree with that. I think that's shit. So we can take his opinion and shove it up his ass.
Brenda, mic check, please.
Can you hear me?
Yes.
Okay. What's up?
You wanted to join the show? You wanted to have a discussion with Tony over something?
Yeah, I don't understand pretty much all that he said. It was almost total gibberish. Light bends. That's called refraction, Anthony.
I'm not responsible for your inability to understand the science that was presented, Brenda. I'm sorry.
So does light bend?
It doesn't follow a curved trajectory. It deviates from straight at every point along the path of least time.
So wouldn't that be called curving or bending?
Deviating from straight isn't a curve. The wave.
Deviating from curve is not a straight? Deviating from straight is not curved?
No, it's deviating from straight is a wave.
Well, light is a wave.
No, it behaves like a wave.
No,
a wave is a behavior, Brenda.
Yeah, it has a frequency.
Yeah, but it's a behavior. It's not a form.
I don't know what you mean by that. Light is a photon. Light consists of a photon, and it travels as a wave. It has a frequency.
They say it travels. I'm not entirely convinced that it travels. I'm not entirely convinced it's a photon either. Einstein says it's true, but that doesn't mean it's demonstrably true.
Yeah, we can see it. So light doesn't travel? What does that mean?
We can see what? The photon?
Yeah.
Really? How do we see the photon?
You take a picture.
Brenda, we don't see the photon. Nobody can prove a photon exists, Brenda.
Yeah. Well, regardless of that, light travels. It has a speed.
So what do you mean regardless of that? That's kind of a fundamental tenet to the idea that light is a photon. It's only a photon if you can prove that it is a photon, and photons don't seem to have any physicality.
Photons don't have a physicality?
No, I said photons don't seem to have any physicality.
I don't even know where to start.
Evidence would be a good start, Brenda.
Oh, okay. Well, I could use actually the photoelectric effect shows that light comes in quanta, which is just another word for photon.
I can agree with that.
There you go. So photons do exist.
Well, I'm not sure. I'm not persuaded either way. I accept the consequence of the photoelectric effect because I've had this with John loads of times, Quantum Eraser, and he argues the same point. And I accept that the photoelectric effect is a thing, but it still doesn't prove physicality. It still proves the behavior that's acting like physicality.
Same thing.
I don't know what you mean by the word physicality. It's well, to begin with, light is energy, and it's not matter. It's not like it's not matter, but it is energy. So it's part of the physical universe.
Yeah, but the problem is,
it's energy.
If light's not matter, then how does not matter travel?
Well, it's energy. It's energy.
Yeah, I can agree with that. But for it to follow a curved trajectory or a straight trajectory, it has to be matter.
No, it doesn't.
No. Why?
Well, how does non-matter travel?
How do you think magnetic fields get from A to B?
Well, there's still physicality in the fields, though, isn't there?
Same with photons and light.
Well, that's another point, but another topic, and I don't really want to go down the light point. I just want to go down whether or not there's evidence that shows that light follows a curved path in the atmosphere or not.
Of course it does. You're the only person in the world, possibly along with, I don't know, one or two idiots in the chat who think that.
Well, I demonstrated that
Anthony,
I'm not the only person.
Have you seen the Lake Balaton pictures where they show a laser?
It curves up.
Yeah, but the whole point, let's forget that. Which way it curves, and you denied that it curves. And so it does curve. So you're wrong. You're an idiot. You're a science denier. And you're the only person in the world, along with perhaps two or three others, who think that light doesn't bend in the atmosphere. You're an idiot. An utter moron. And you didn't understand that video where the light came from the back and the light was not shown to be bending. It changed intensity. The light was shone from the back. They had some polarizing filters on the camera. So, of course, when the light was rotated, it changed the intensity for some sugars and not others. And there's nowhere in that video does it show light being bent in its path of its travel. It didn't bend at all. It just changed the intensity. You didn't understand your own video. You are an utter moron.
So if the light's being bent away from you or towards you, depending on which way the the polarized filter's moving, you would perceive that as a reduction or an increase in intensity. But it doesn't change the fact. It doesn't change the fact that the light is being bent.
Ben, I've got one more point, one more key point.
Okay.
Changing the polarization of light does not change its direction. You go and find somewhere, anywhere on the internet, which claims that changing the polarization of light changes direction, because you won't be able to find it. It's something you've made up, presumably you got from Bob from Globebusters, who's another utter moron. And you two, and perhaps two or three others, are the only people who think changing the polarization of light changes its direction. It does not. It's a scientific fact that changing the polarization of light does not change its direction.
Yeah, it does, though. It was demonstrated in that video.
No, it doesn't. That video does not demonstrate any change in the direction. It demonstrates a change in intensity. The light's coming from the back, you moron, coming into the camera, and they put a polarizing filter on the camera. So when the light is rotated, i.e. having its polarization changed, the filter on the lens on the camera then changes intensity. Jesus Christ, you're an utter science-denying, reality-denying moron.
Yeah, we would perceive a reduction in intensity if the light's moving away from you as well, though. You're not making your point.
You didn't understand the video. Go and find somewhere that claims that polarization changes the direction of light. Go on, go and do it now. You won't be able to find it.
Go and watch that video, Rumpus.
I have watched the video. I understood it. You didn't. Go and find a citation on the internet that says that the polarization change causes a change in direction of light, because it doesn't, and that's fundamental to the whole point you made. Changing the polarization of light does not change its direction.
If what you said was true, all three lights would do exactly the same thing, but they didn't.
No, they don't. They change in intensity, you more. The light's coming from behind. There's no light ray you can see that's changing angle, is there? All you can see
the light
is
ray's missing it
in intensity.
Yeah, because it's diffracting the light away from you, which you're claiming is a change in intensity, but it's actually the light moving away from you.
It's not changing the direction of light at all. It's just changing the intensity.
Of course, it's changing the direction of light, because what the
Go
middle.
and find a citation, Anthony. Go and find a
I've
citation.
just demonstrated it, Rumpus.
No,
Anyway,
go
listen.
and find a
listen.
citation. Go and
Listen.
find a citation that changing polarization changes the direction of light. Go on.
You're reversing the burden of proof. The burden of proof is on you to demonstrate that light curves in the atmosphere, not on me to prove that it doesn't.
But
Anthony,
you and your dog thinks that's the case. You're the only person, along with Bob the moron and possibly 2 or 3 others, who deny that light bends in the atmosphere. The Lake Balaton thing was got pictures, video of laser light being bent. There it is,
going through
white.
Yeah, but the problem is it was going the opposite way for you, and we know that it'll do that through
It doesn't
vapor.
matter which direction it went, Anthony.
Yeah, it does because it bends away.
Hold on, Anthony. Bending one way or the other is not the argument here. You're claiming it does not bend, and that video demonstrates that it does.
Rumpus, if the light is being bent away from the normal, like it did in the Balaton thing, in that weird set of refractive effects, well, that's going to cause you a major problem in trying to argue that it bends around the curve of the Earth.
I'm entirely happy with that. Just demonstrates what an inferior mirage does. That's the cause of an inferior mirage. But let's not. I know you try and deflect off the point. The point is, you are. The point we're dealing with at the moment is that you claim that light doesn't bend in the atmosphere. That video of a Lake Balaton by those flat earthers demonstrates that it does. It contradicts what you said entirely.
It works Anthony. In my favour.
Hang on, the lake? Hang on, wait. Let's
say that light can bend.
Hold on. I want to see this lake.
Utter moron. He's denying
this Lake Balaton. This Lake Balaton video. Can you tell us about that?
It shows a green. It shows a green. Isn't it a green laser? Is it a green laser? I think. Yeah. And it shows the laser light bending upwards. So light will bend upwards or downwards depending on the conditions.
Prove that it bends downwards.
It's not the argument.
Following a curve. Following a curve.
The argument we have at the moment. We can move on to that. I'm happy to move on to that. Your claim is that light doesn't bend in the atmosphere, and I've got hopefully you can see my screen.
Yeah, I don't want to see pretty pictures though this time, Rumpus. Just bring citations.
From the video, there's a photograph from the video, Ranty. Shut up.
Greater Sapien has a video showing him bending laser light up and then down.
Where is it? Here we go.
Whether you heat the air or cool the air, it will change the direction. Anthony.
Yeah, but it needs to follow a curve. It needs to follow a curved path, not just one change in angle.
What do with it?
That's a good point, Tony.
So
he's current.
So Anthony, if you have a gradient, of density in the air, either going from high to low or low to high, that will result in a curved path. If I put a pencil in a glass of water, that bends the light, right? You understand that, right, Anthony?
Yeah, because you've got a boundary change, a hard medium change.
Yeah. Well, that's what you get in the air. You have dense air, typically close to the surface, and then what?
Do you understand what non-isotropic means?
What does that mean, or how are you using that word?
It means that it varies from point to point. Yeah, that's one bend, that Rumpus. That's not a curve.
But a gradient.
All that light needs to do to generate infrared. You claimed that light does not bend. Here we have visual proof that it does in the atmosphere. You utter science-denying, reality-denying moron.
Not a curve. That's one change in angle.
Brat. Look, it's bending down and it curves up. What more do you need?
God,
you're just denying what's in front of you, you idiot.
Put a straight line on the other angle there and show that it's just one angle change because it's gone through a little change in density or humidity or temperature or whatever it is that's caused it. It's changed it angularly, not curved. It's got an angular change through that part there.
Just to draw.
It does look like one change of direction, to be fair.
But the point is, Rumpus, when it does it from point to point to point along the ray, how are you going to get that to follow the curvature of the Earth when it's moved up once?
Oh, okay, that's simple. Anthony, it's because the density of the air varies smoothly from being close to the surface where it's very dense to less dense as you get higher, and therefore that it will follow the curve because the density of the air follows the curve.
Right, take those lines out, Rumpus. That's wrong. I want you to start.
I have to put a Bezier curve.
No, you don't have to put any curves. Stop putting curves.
I do absolutely.
Just put a straight line on it, Rumpus, and see how it matches.
Just put one straight line in from the end, the end at the top right. Yeah, take all those lines out. He wants his curve, doesn't he?
There we are. There's the curve.
You're not in the middle of the beam. Just put a straight line in the middle of
What
it.
do you think I am? What do you think that is?
Just
there.
take
That was
that away.
All in the middle of the beam. That's in the middle of the beam.
Bollocks.
What are you talking about?
Right. Could you do what we asked then?
Hold on.
Not
Start to save. Hold on, I've got to stop it from saving. Oh, bloody thing does. It's backing
That
up.
would be in your preferences, wouldn't it, Rumpus?
Yeah, I know. I keep on having it ready saved. Yeah, unfortunately, it locks up before I get a chance to fiddle with it again. I have to wait until
Because your
it's up.
document is too big. Break it up
Yes.
into parts.
Well, it means I then
I
can't
just-
scroll around it easily. Thanks for the tips.
Oh, okay.
Unfortunately, I'm going to have to wait until it's.
Publish the damn thing already.
Well, it's got
2 years.
it's got lots of bits in it, and I haven't really, and I'm adding to it at the moment. Actually, I haven't done much on it for 9 months, and I'm adding a bit more to it now.
But it's always a cold that you've got that stops you from presenting it.
I've had a really rough period of the last month and a half with my flu, I'm afraid.
I'm sorry about that.
Well,
What about the other
But
23 months?
That green laser looks like it's curved up to me.
Yeah.
Right, put a straight line through the bottom end of it, Rumpus.
I'm afraid it's decided it's going to save it, come what may, and I can't do anything for about another 30 seconds.
That's because you went to the curve. You just needed to put one line in and it was there. It was like one change in direction.
It does a save every half an hour if I have changed it, and I've changed it there, and obviously immediately spotted that, and off it went and saved the damn thing. And it's 200 pages worth of stuff, and it takes a long time to save it.
Hey, Rumpus, let me just interpret this the way that you would interpret it. I'm going to do what you do. This is not my position. This is the way you do it. What I would argue if I was you, I would say there's 1, 2, 3. There's 4 points there, and I would say 3 of them are now bending away from the normal because it's gone through an extreme amount of refraction because it isn't deviating from straight. So it's extreme amount of refraction, and that really is what you're looking at. That's how you would.
Isn't that curved? Isn't that green light curved?
In fact, I have to curve it more to keep it in the middle. I actually have to curve this. I have to move this further down, actually. So
Well, just put a straight line on it, Rumpus, like we're asking you to.
Okay, I'll
But
do that in a second.
Anthony, isn't that curved? That's a curve.
It deviates from straight at every point along the path.
That's what a curve is. A
Yeah,
deviation from straight.
I mean, I thought you were pretty stupid, Anthony, but to deny what a curve is, I mean, that's taking it like you're basically saying that 1 + 1 is equal to 3. I mean, it's that stupid. I mean, it's just
Anthony, isn't that what a curve is? Is a deviation from straight.
No, Brenda, because if it's
then what is
from
it?
straight at point to point to point along the path, then every point along the path is from straight, not following a curve. It's from straight, Brenda. It's the antithesis.
What does that mean?
Well,
Rumpus, what does that even? Rumpus, what did he say?
I don't know. It's just gibberish. I mean, anybody who denies that light bends in the atmosphere, I mean, it's almost, you can almost just say, what's the point of talking to someone like this? They're basically denying basic facts. I mean, I know he's a flat earth and you can say he's really stupid for that, but this is taking it to a basic thing of observation. No one agrees with you, Anthony, in the entire world that light does not bend in the atmosphere.
No one disagrees. No one disagrees with the desire for light to change direction, but we're talking about concentric with Earth curve. Show us that.
That's another issue. Right. So
yeah, we know that.
Yeah, but
Okay,
we're just trying to get to whether or not this green light is curved or not. It looks curved to me.
They just conceded that it changes direction. No, we see that.
Well, that's
fine.
curvature.
Correct, but now we're worried about concentric with Earth curve.
Anthony says it's not curved.
We can go into how it's curving. I'm perfectly happy to do that.
They just admitted that. Why would we not concede that that's changing direction? Everybody.
Well,
can see
Anthony says it's not curved.
Yeah. Anthony the moron, he's facing so much denial here. I mean, it's almost not worth talking to him
He
at
just
all.
said it changes direction. We all
Yeah,
see
but
it.
he says that changing direction doesn't mean it's curved.
Yeah,
It's
it
not.
doesn't.
We're worried about Earth curve.
Yeah, okay, but Anthony's onto some other subject. He's such an idiot. He's trying to deny basic things.
Right, can you... Well, hang on, wait a minute. I want to get this sorted, right? So, Rumpus, I need you to take those lines out that you've just put in, please. Can you remove that black line? Yeah, get rid of that, right. And now, you see the top right-hand side of the green part, yeah? Right in the centre. Go right into go right into the end and right in the centre. And then
that's the centre of the blob.
Yeah, okay, centre of the blob. And then go in a straight line right down the centre of that that green thing right to the red point, to the red line that you've got in, right to the red line, and keep one straight line.
What?
Yeah, and
What?
keep it in between the laser.
Yeah, right in the middle of the laser beam. Just aim it towards the center of the red line that you've got already going through the green line.
What?
Rumpus. Head for 7 o'clock.
He's been kicked, hasn't he?
No, he's there.
No, I think he's dropped.
Oh, his program Zara designer probably crashed.
We nearly had him. I see one change of direction there. I don't see like a multiple change.
It's a curve.
Changes.
It's a curve.
No, it looks curved because it's one change.
Yeah, as it's changing
not
from the
one
density
change.
gradients. There's a change in either the temperature. Brenda, there's either a change in the temperature, the density, the humidity, or the something else, whatever the fourth factor is, and that's what you're seeing there. The change, but it's deviating from straight. That's just going away from the normal at that one location. If you do that in a straight line over 20 miles, you're going to get lots of them that vary along the way. Some of them go up, some of them go down, but they're not following a curve.
Agreed. Yep. Correct.
But that's just wrong. So if you have a smooth gradient it's a temperature gradient that causes light to refract. And so if you have a gradient from dense air to less dense air above the surface of the water, you're going to get a curve. That's what refraction is.
So that light that you saw then, was that following 7.6R? Or was that more like 9.6R?
No, it was going the other way, Ranty. It wasn't following any 7.6R.
Yeah,
it was following 2R, 2 over 6R.
Well,
it's actually
it's curving because of the air, because of the density of the air of the medium that it's traveling through.
So
at one point, but what happens when the density changes again at the next point along the ray, and it comes back down again, Brenda?
Well, do you know what a gradient is? It's a continuous change from dense close to the surface to less dense higher above it.
Well, that wasn't continuous, was it? That was major. That was major fucked off into space. That.
Yeah, the other thing is, Brenda, if the Earth's fallen away from the beam at every point along the ray path, right, that means it's always getting less dense, which bends the light away from the normal, which bends it up.
No.
Yeah.
No, the density follows the curvature of the Earth because
no, it doesn't.
That's the Earth.
No, it doesn't.
Yes, it does.
The density is falling away from the laser line at all points along the ray. So the further away the ray's going,
not really.
Yeah, the Earth's falling away, and that means that the ray's going into less dense medium because the Earth's falling away from straight.
The Earth doesn't fall away. The Earth
it does.
Is
geometric
curved
drop
everywhere.
Yeah, it falls away from the straight line of the laser.
Yeah, and the density gradient of the temperature of the air follows the curvature of the Earth.
Yeah, but the density gradient of the curve of the Earth means that as the straight line laser's going away from the Earth, it's going into less dense medium, relatively speaking.
Right.
That means it's bending away from the Earth's curve, not towards it.
Well, there's conditions where it will bend the other way. It depends on the atmospheric conditions, which way the light will bend.
You'd have to have an inverted atmosphere for that to do that, Brenda. You'd have to have.
We have those conditions. They're called temperature inversions.
Yeah, but that's only one factor: temperature, pressure, density, and humidity. I think the 4 of them are.
Well, sure. Those different conditions can all come together and to give you refraction.
But when you've got that curve,
different directions.
When you've got what you call the curve going away from the Earth, how does it then get it back down again to at least level to follow the curvature of the Earth, which is bending away from it? Because you've got to have it going totally the opposite direction with pressure, density, humidity, and whatever the other fourth factor is. Then things have got to totally invert for it to come back down again.
What do you mean come back down?
Because if they don't change their polarity and become the opposite of what they were, the light's going to stay straight or curving away at all times. It's never going to follow the curve of the Earth.
Light bends due to the density primarily of the atmosphere. Right?
Follow a curved path, that's the point.
Yeah, it follows a curved path.
No, it doesn't follow a curved path, that's the point.
Well, but you could see it following the curved path.
It wasn't. It was changing its direction at that point along the ray path. Sometimes it goes up, sometimes it goes back down again. It depends on, and the deviations are small over the ray path.
But it doesn't sometimes go up and sometimes go down, because the gradient of the atmosphere is consistent. It's not erratic.
No, it is erratic. That's why that's why Skunk Bay exists. If it was consistent, Skunk Bay wouldn't exist.
I don't know what Skunk Bay is, but yes, there can be conditions that are different than the typical conditions. But the typical conditions are that there is a consistent gradient of air above the Earth's surface that follows the curvature of the Earth, right? That results in a consistent bending of light in a specific direction.
No, it's not a specific direction. It's in both directions, and it varies from point to point along the ray path.
Correct.
That's what the science just said when I read it to you. I know you probably weren't listening, but that is what it said.
Well, you can just deny it, but light bends in a curve based on the density of the atmosphere. That's why the sun.
It deviates straight, Brenda.
That's a curve.
It's not him denying it, Brenda. It's you. He literally read exactly how it's termed, and then you said, "Well, you can deny it." No, well, it's you that's denying it, because it says it there in black and white.
Says what?
Deviates from straight.
Yeah, that's a curve.
No, it's not.
No, it's not. What happens if it goes? All right. Well, okay. So if it, so what? Okay. So what happens if it goes at 90 degrees? What happens if it deviates at 90 degrees, and then it deviates at 90 degrees again, and 90 degrees again? What happens then? Is it curved?
Circle.
No, it would be a square.
Yes, but you don't have that's called reflection, not refraction. That would be if you get a 90 degree, that's a 90 degree reflection.
Out of interest, did somebody kick Rumpus, or is
No,
he dropped?
no, he's just.
No,
He's,
I did. Well, I don't have the ability to kick anybody.
no, he's just dropped. He's probably rebooting his PC. You know, he's got like 60 tabs open or something. I think that's probably him messaging me now. Let me just check. He can just join. He can, because he's already part of the. There you go. My internet connection has failed for various protocols. Okay. You didn't bullshit enough.
just tell him that Riley said he ran away. Just to piss him.
Riley said, right, okay, you guys carry on.
Just say Riley said he ran away.
He's yelling at his internet service provider right now. I'd love to.
Yeah. He's gonna punch his computer screen when he reads that I said he ran away.
Protocol error. Fail. Rumpus, you failed.
Brenda, don't you think that that's odd, though, that the atmosphere would have to be so perfectly tuned for a light to travel in that perfect, concentric with Earth direction? Like, you don't think that would be such a rare occurrence?
Can you see this? I really suck at trying to share screen on this. I'm not used to Skype. Are you able to see? I'm supposedly sharing my screen.
Not yet, Brenda. We're not seeing it.
Actually, I don't even see you. Oh, there you are.
Oh, he's back. Apparently, he's back.
Is this sharing? This image?
He says he's back. Bloody MI5. No, you're still not sharing there, Brenda. But yeah, I'm looking at that image, and that if that curve was how light behaves, then we would live definitely on a basketball.
No, we would live on a concave Earth.
Yeah, but I mean, but I mean, that.
Oh, here we go.
That's amazingly big.
Thanks.
There we go. Brenda, you're back on.
Are you seeing this image?
Yes, we are.
So, this is refraction, due to this is atmospheric refraction.
What type of refraction is this?
It's just I don't know. It's just atmospheric refraction.
Well, there's only 5 types.
Hang on, hold on. I've got this. Go on.
Go on then.
And it's and this is obviously due to this is due to the density of the air, right?
Okay. So what happens when it goes right above you and you're looking just straight down from it? Surely you should be looking at its relative position, yeah?
Well, yeah, you get little to no refraction when the sun is above you.
So how come this
is a curved line. Are we in agreement that this is a curved line?
We're in agreement that this is showing a curved line. So if that's the case, Brenda, how come we see a 15-degree change every hour?
I'm sorry. What do you mean a 15-degree change?
Well, if it's changing from refraction, so it's not in its apparent position, it's not in its real position right now. It's somewhere else, right? It's just perceived in that position.
This would be a superior. This would be a superior mirage. So
this
is the sun.
So when
the sun is above the sun is above the horizon, or perceived to be above the horizon, when it's physically below the horizon due to refraction, due to atmospheric refraction.
So it's not really there to start with. It's not in its real position to start with. But when it's directly above you, it's in its real position. Yeah.
Right, because there's little or no refraction going on at that time.
So how has it moved 15 degrees per hour then, if that's the case? You've already shown in this diagram here that it's a full sun's diameter away from its true position.
Well, it's just an illustration. I don't know what the exact amount is.
You see, that wouldn't work, what you're presenting.
Why not?
Oh, and by the way, the Rumpus, you can just join. You just need to click the link. You're already in the group. The Mind of God, do you want to take over here? Have you got something to say?
Well, our argument is, let's say there's 2 objects on the Earth. That's what I want to see, the light bend. Let's say the light is going through one density profile that's curved. We don't have any comfort. I don't have any comfort in how that light will curve around the Earth. What's motivating it to do that? We don't need to see anything that's way out in another.
Sure. What motivates light? What motivates light to change its direction is the change in the density of the medium through which it's traveling.
But let's say it's along the surface of the Earth. That's my point. Let's put 2 items, feet on the ground, and then show how the light.
Well, we're just dealing with the principle right now, because we have conflict over whether or not the refraction even exists.
No, we're comfy with that.
Right? Can we?
No, Anthony's not comfortable with that.
Oh, okay.
Well, refraction doesn't exist the way you're saying it does. There's 5 known effects of refraction, and curved light is not one of them.
Oh, that's
hang on. Hold on, Rumpus. Hold on. Can we just hold on? Can we just confirm, Rumpus, that you're an utter moron because you didn't need to be invited back? You just had to click this link.
I lost all connections, and Skype therefore did not allow me to just jump back into the call. You had to invite me.
I didn't invite you. Nobody invited you.
Oh, well, the option only just came up just a few seconds ago. Someone must have done something.
The shit.
The button only just appeared just now. The button only just appeared just now. I assumed you'd invited me.
Ranty, I invited him. Let's just give him a pass.
So there we go.
You did invite him.
You're a moron. You're a moron.
No, you could not do that.
I didn't, man. I'm just kidding. I know we didn't. Bad with Rompus because Ball Earth is taking so many L's the last couple of weeks, so I'm just giving him a phone.
I lost everything. The whole bloody internet connection went down.
Yeah, but you're just part of a group. All you had to do was just click group, join.
It did not have the join option visible. It only appeared just a few seconds ago.
Right, Rumpus. So about that.
Well, this is irrelevant. But
about that straight line, Rumpus. Do you want to put the straight line in for us?
On the image I had, okay.
Yes, if you wouldn't mind.
Well, I did it before, just before everything went pear-shaped. Right.
Well, you didn't. You put in lots of little lines.
No, I did put a straight one in. Obviously, you must have missed that. Must have gone down prior to that.
Yeah, make sure you get it in between. Put it in the middle of the laser, so it's in the middle.
God damn. Oh, I shared the wrong thing.
Don't be sharing your porn now.
Ranty said you ran away, Rumpus.
Yeah, well, you can't cope with a little bit of life interfering with things. Anyway, so we've got that. Here we go. Right. Jesus Christ. Right, so here we go.
Yeah, get rid of that. Oh, what have you done there?
Are we back on track now?
There's a straight line from the centre. You told me to go to the... You told
Get the angle right, Rumpus. Put the angle correct. The angle's incorrect. You've got it touching on one side, but then not touching on the other.
There we go.
There you go.
Well, that's not straight, is it? You can see that it's become thicker up here. It's going towards the top there. It's touching it there.
Rumpus, pull the bottom in a little bit more.
What do you want me to do with this point? Up, down, left, or right?
Put it towards the right a few more pixels more.
Right, so now it's not... So it's still not... It's still too to the left here, there. It's curved, Anthony. You're just denying what's in front of your face.
No, it's not... Rumpus, pull that bottom of the line towards the right a little bit. There you go. Now, does that look like it's curving?
Oh, yes.
No, it's just it's bending at that one point because there's a change in temperature, pressure.
But that's not following. That's not following the path of the light, Anthony.
Yeah, all that's happening is there's a change.
I have to put in several lines here.
No, that's the point where there's a change. The pressure,
I have to put
density, the humidity.
Okay, right. So if this curve or quote unquote curve,
still not. I have to put in more.
Hang on. Let me just join into the
dude,
call.
the light would have to curve all the time. Can like all the time, like at every point. If it's on a ball Earth.
Correct, and it does.
But you're just showing us one. You're showing us one kick point there, one knee. We need to see that it. Why would it constantly do that to travel around?
The reason this happened was because they shone the light down, and then it entered this is the cause of inferior mirages, and it entered this thing, and therefore it was bent up. Now, if it carried on, it would start to bend down again.
Entered what thing?
The inversion layer. This is what causes inferior mirages, as I explained in the presentation I gave to Ranty a few days ago that you obviously didn't watch.
What has it entered?
An inversion layer, where the air is warmer down here, less dense than it is above it. So that's what causes inferior mirages. We've got a negative K value here. The light's bending up, and this is what causes inferior mirages.
So would you agree that would you agree that those light rays that are demonstrated on screen then can't follow the curvature of the Earth?
They can do. They will. They'll start to curve the other way eventually. But because they... I mean, are you so stupid? And I appreciate you and Ranty have difficulty understanding the presentation I gave the other day. You just say blanked off because you're stupid and did
Hang on.
And you can't accept information. But I did explain quite some detail how the light that goes towards the ground is bent up in the inverse case of the laser in the tank because the air is less dense after a warm day at the bottom than it is on the top.
So this.
When you say eventually it curves the other way.
Look, here we go. This is what will happen to it.
How far away from the curvature of the Earth profile would it be at that point? And how would it get back down again? Because where would the increase in density be for it to bring it back down?
Exactly.
That's a good point. Where would the increase in density be in the atmosphere for it to bring it back down?
You morons! You haven't understood that.
No, just show it on that. Put your image back up.
Hold on, I can explain to you.
No. Please put your image back up.
I'm going to explain it to you, which you didn't understand in my presentation.
I want to see it curving back down.
No. You're going to have to understand it more simply here first, and then we'll develop onto that.
Ranty, be patient.
You are
Ranty,
stupid.
be patient. This is the premier optical expert. Remember.
Well, Rumpus, can I just say, Rumpus, can I just say good evening whilst you thumb through your pages? So you're all right. You're safe. You're not get pillaged, but that's really cool. That's the Lake Balaton stuff, isn't it?
Correct.
Which is really cool because it's again another confirmation, a bit like Dr. John Dee's work, that if light does have a
yeah, it's really good. Yeah, the global Earth. Yeah,
unfortunately goes the wrong way for you ballers.
Right, here we go. So this is what
the wrong way.
That's irrelevant.
This is what happens in the tank.
Goes the other way.
How many pages How many
Anthony,
pages that stupid
Anthony
document
misunderstood this. He didn't understand this in the argument he just
Randy,
made.
Randy,
Randy,
I know Rumpus going to talk.
You get a chance to
Did
speak.
you hear that point, Randy?
It's not your turn at the moment. You get a chance. Behave like an adult. You'll get a chance to speak in a second.
I did.
Middle of a
I
second.
did. You just carried on and ignored my point, didn't you?
Be quiet.
Like a child.
Behave like an adult. You'll get a turn to speak.
Little boy.
You'll get a turn to speak in a second.
Didn't you?
You'll get a turn to speak in a second. Stop being a twat.
Mute.
Stop being a
Just
twat.
relax.
Behave
Stop being a twat.
Oh, come on, guys. Come on, guys.
Adam, I'm in the middle of
I need to take control. Come on, guys. Right, behave.
Stop Adam behaving
Please.
like a twat. Right. So here we go. Right, so here we go. I was explaining. You were asking. You were asking why the light would bend down, and Anthony didn't understand
nonsense
what was
that you
happening.
got from
He
your
didn't
Tavistock
understand how the light would bend
Right,
down.
come on, guys. This is no good. This is no good for the audience.
Despite me having to explain this,
Seriously.
I'll do it again. I'll do it again.
Right, I'm just going to have to mute you all.
Do it again.
Right, so you're all muted.
I was busy explaining to Anthony how this works, and he didn't understand it.
By the way,
before.
all right, mate.
He didn't understand it before. We'll try again. So light, when you have a greater density down here, as this diagram demonstrates with Snell's law, it bends away from the normal when it's going up, and it will become horizontal, and then it will start to bend down, and it will bend towards the normal.
So it bends up, then down.
Correct. Yes. No. Sorry. It's
Up,
bending
then down.
No, it's bending down all the time. So it's going. It starts going up.
You can see it's bending up, Rumpus.
No, it's bending down.
I was with you when it said it went up, then down, but it goes up clearly. Look.
Yeah, but how can it go up then down, Rumpus? Sorry.
Just listen. Try.
Are you saying
Rumpus? Roller coaster world. It's not ball world anymore.
I'm trying to explain to you. Here we go. We have greater density down here and less density up here. And as this diagram, which represents the Snell situation, when you go from greater density to less density, it bends away from the normal. It becomes more
a roller coaster atmosphere.
Be quiet.
Is that what you're saying? The atmosphere isn't graduated. It has different
positive
and
so
negative.
when it gets to horizontal,
and
it will then do the carry on bending down. So it's
that's what I'm saying, Rumpus. So it's not graduated in a collimated way.
Let me
there are actually positive and negative changes in the collimation. Is that what you're saying?
Then you can ask your question.
Answer the question, because it's pertinent.
About to finish,
and save you rambling for another 5 minutes.
I'm about to finish, and then you can ask your question. Right, so here we go. So it bends.
Then. So is the atmosphere collimated in a graduated way? Or does it have variances in the density, showing positive and negative variance as you go up?
Not interested in what you've got to say, Adam. So here, if you follow Snell's law, you will see that it will bend as it goes into a greater density. It bends towards the normal. So that means it will form an arc. It will form an arc.
Isn't it, when you have to answer this, Rumpus? It's going to really hurt.
No, you haven't finished yet. You get a chance in a second.
I'm going to kill you.
You get a chance in a second.
I'll come back. No, I'm quiet now. It's coming, Rumpus.
You get a chance in a second, twat. So hopefully you understand now, Anthony, that it will form an arc and it bends down continuously towards the
Anthony. It'll go down to form an arc.
Just hang on a sec, Adam. Let me ask you my question. Rumpus, can you go back to the picture of the green laser? Balaton. Yeah, I've understood it. Go back to the Balaton picture.
Explain to me then what will happen, why it's bending this way and why it's also bending at the end. Explain that to me.
1 second, guys. I'm going to share my screen because I know what Tony's going to do. I know what Tony's going to ask, so I'm just going to share my screens.
I'd like to answer my question.
Yeah, well, you'll see it in a minute, I'm sure, because I'm pretty sure that this is what Tony's going to want to do. He's going to want a comparison between the two. Am I right?
If I'm right in understanding, because I'm a bit thick, Rumpus, are you trying to say that the Balaton laser at the bottom is not actually bending up, it's bending less down?
No, it's bending. These are two different circumstances, you twat. I've been trying to explain it to you. I've explained it to you several times. It's not the same. There's a greater density in my laser tank at the bottom, but the opposite is the case for the water. There is warm air. Now, let me just listen. Just try listening and understanding for once. near the water, because the water is warmer than the air around it, the air above it, the air near the water is warmer than the air above it. So it's the inverse of the case of the laser tank. Therefore, light will bend in the opposite direction to the laser tank case.
So just clarify, is that
That's
up?
why
Or
I mentioned earlier, it's the inferior mirage case.
Rumpus, is it up or is it less down?
What is?
When he said that the light will bend in the opposite direction, do you mean that it'll bend up or do you mean that it'll bend less down?
Just listen to what I'm saying, Andy. Try and engage that small dormant organ in your head. In the case of the Lake Balaton, as with inferior mirages, there's less density near the surface of the water. In my laser tank, there's more density towards the water.
Which?
Hold on,
so
I've got two more seconds. 2 more seconds, Anthony.
Let him go, Anthony. Let him go, because this is brilliant.
Just
let him define this exactly, please.
Shut up,
it's fantastic.
So they're going to bend in the opposite direction to one another, because at the bottom of the air here, it's warmer than the air above it, therefore it's less dense, like you have in inferior mirages, whereas in my water tank, it's more dense towards the bottom. So they will bend in opposite directions. Do you understand?
Right. So opposite being up and as well as down, or are you saying that it's less down?
Oh my God, you stupid moron.
Just answer the question.
This ray of light, the one in the Lake Balaton, is bending up. The
Excellent.
one in the laser tank is bending down, because there are two different situations.
Well, yeah. So which statement is true? Well, is it that they deviate from straight, or is it they follow a curved path at all times?
They follow a curved path at all times,
even though it's curving up.
Yes, that's a curve unit. Curving up and curving down is still curved. You utter moron.
Yeah, exactly. Jesus that's kind Christ. Of my point.
You are
Come on, Riley. You can see that it's both curving up and down at the same time.
Yeah. Are you really
it's clearly going down whilst going up.
Do you not regard curving up as a curve?
Going down whilst going up, man.
Your argument is that it follows a curved path, following the curvature of the Earth as it does so.
No, not always. Not in an inferior mirage case. You utter twat. You utter moron. You've got two situations. One in an inferior mirage when it's bending up, and normally with standard refraction when it's bending down. You can't cope with two concepts in your head. You are a moron of an unbelievable scale. You are an utter moron.
Standard refraction.
I think he's having a go with you there.
Do you manage to tie your trousers together in the morning? Do you manage to put your shoes on? Because that's what you're demonstrating. You can't cope with two different concepts. In two different situations, it bends in different directions.
Yeah, okay.
This is just a wind-up. I think this is just a wind-up.
But Rumpus, the issue is that the curvature would add to that mirage, right? Because you have a drop-off, so any of those superior mirages would be magnified by the fact that
what's this got to do with superior mirages? What? Sorry, what have you wandered off into now? What are you talking about now?
You just said the light can go up or down, right? Depending on the channel or the characteristics of the atmosphere, right?
Correct.
That's what you're saying? Yes. Okay, so if we lived on a curved Earth and we had an image that's up, superior, however you say it, the curve of the Earth, if somebody was standing on the Earth, it would add to the effect, right? It would be the light bending plus the drop-off. That would be the amount that it's elevated.
You're...
You see what I mean?
No, you're stupid. But I will now explain to you what you're trying to understand here. Oh my God!
So I was asking a question.
Yeah, I know. The question is stupid, and you'll realise why it's stupid when I show you this diagram.
Just put two people standing on a ball Earth, and then
here we go. Monaco,
can
you see this diagram here? This will explain it to you. Right here we have curving light that curves down due to standard refraction. See these red lines? That's standard refraction here. It bends like in the laser tank, because in normal standard refraction, unlike in the inferior mirage case, standard refraction with a standard atmosphere means that air near the surface is denser, because like the bottom of a swimming pool, it's denser because you've got all the atmosphere above it. It's denser at the bottom, and
those rays are all curved in the same direction.
Showing me a picture of reality and telling me I'm observing
hold on.
Over a ball.
Those rays are all curved in the same direction.
That in real life, in any way, shape, or form, over that distance.
And over talking me, you twat.
So no, I'm just asking you a question, which goes to the fundamentals of your whole premise that you're asking us to believe.
But Adam, wait, let him just finish this point. Yeah, just let him.
Right. So, as I demonstrated, that with standard refraction, light curves around the Earth. And you can see here, that's what it's doing. And that
But
means...
Rumpus, this is the point.
All curving.
One of those arcs.
Hold on.
I'll refer you to my previous question.
I'm
Can
nearly
you
there.
demonstrate that
nearly there,
in
mind of
anything
God.
other
Just
than a
give me
real-life
a few more
photograph
seconds.
where you ask
Mind
me
of God,
to
just give
pretend
me a few more
that the
seconds.
flat image that I see...
So here we go. So the light bends around the curve of the Earth, and when it hits the observer here, the observer treats the light as coming in a straight line. And so this lighthouse, the light, because it's curved this way, will then draw out these straight lines and perceive it here. So it'll be loomed up because the light curves around the
fur
coat. Do you understand that, mind of God?
Right, go up to the next image there, please.
Hold on. I want to ask, mind of God, did you understand that explanation?
Well, actually, no. I want you to see one of those red arcs that you've drawn from the top of that lighthouse to the eye. Yes. My point is that along that red line, just from a high level, tell us what the pressure or whatever the density is in that space. So start from the top of the lighthouse and then go over to the left. Tell us, go high, 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 low, low, low. Like walk us through. What is that experiencing?
Okay, so here we have light emerging from the top of the lighthouse.
Yes.
And we're going to
do the top one. Do the top one. The top
and we're going to take the light that's moving horizontally from the top of the lighthouse. But that's the way. We could consider a ray that's going up here, but I just happen to know that the one that goes horizontally will hit the observer. So I'll tell you what happens. So there's a density gradient. The air is more dense towards the Earth than it is above it.
Wait, just tell us, which line are you, the red one or the black one? The middle
red
one or
the
one top red one? Okay, good. Just so everybody can see. Go for it.
Can you not see that? So here we go. So here's the lighthouse. We're going to consider a light ray from here. That's going to go semi-horizontally. Now, there's a increased density towards the Earth and less dense up here. Following the rule in the laser tank that you've seen earlier, it will bend towards the area of greater density. So that's where this curve comes from. It's bending towards the area of air that is more dense. That's basic refraction. So it goes along this bend and it hits the observer. The observer thinks it's a straight line, not a bend. And so the observer perceives the top of the lighthouse up here. And this is basic looming that happens with standard atmospheric conditions. There it is. That's where it's perceived. This is where it actually is. The light has bent around the...
Good. So now the issue is with the bottom one. Let's say that there is no change. How does that have the intrinsic desire to curve around the ball Earth? Yeah, that's our issue right there. Let's go through that one. The very bottom. Yeah. Right.
The bottom one has exactly the same situation. The air above it is less dense. Now, it's right on the ground, but it doesn't have to make a difference. But immediately it gets away above the first molecule of air, it'll find air that's more dense towards the Earth and air that's less dense above it. Following the rule in the laser in the tank, it'll bend towards the air with a greater density, which means it will form this curve just like this one. The rule's exactly the same. The density is exactly the same direction.
No, Rumpus, no, but you're missing the point. You walked us through the top red line, which was good, and it's curving down towards the eye. Fair enough. Now, see the lighthouse, see that bottom red line, that bottom red arc? Walk us through that. Okay. How is that curving perfectly around Earth to meet the person's eye so we can see the base?
Okay, well, it has exactly the same rules as the light ray up here.
Walk us through it. Walk us through it. No, it's not, because it's going through. There's no elevation change.
There is. You can see that. You can see it's pointing. Right. It's pointing in this direction. I'll just put an arrow on here.
It's going to an increased elevation above the surface, right? Because the person's eye is above the ground.
Back before it does that.
Wait, Rumpus, just do you agree with this? We're talking about the base of the lighthouse, which is on the Earth, reaching a person's eye, which is above you.
Yeah. Here. Sure. You have this red light. Yeah, this red ray here. We're talking about this red ray here. Right.
It's hard to see, but the bottom one.
Right, so we're going to assume we're going to have a horizontal ray from here. It's going to begin life going in a straight line horizontally from the base of the lighthouse.
Correct. Yeah.
Right, and as it carries that horizontally, the Earth falls away, and so that means it'll find itself slightly above the surface of the Earth. If it carries on, if I draw a horizontal line from here, if I do this, if I draw just a straightforward horizontal line, it'll find itself increasing in elevation. Okay? So just by going horizontally, and it will then follow the rule in the laser tank that it will bend towards the greater density of air, which has the greater refractive index. Everything bends towards the area of greater refractive index, just like the top ray. So it'll bend, following this red line, it'll bend towards the Earth, just like this ray up here, bent towards the Earth in a curve, and then it'll arrive just like that at the ray here, and then it'll be perceived by the observer following this dotted blue line here, and that's where it'll perceive the base. The observer will perceive the base of the lighthouse here.
So you should technically never be able to see if let's say the other person is observing on the Earth itself. Let's say there is not that elevation change. There is no desire for that ray to curve around the Earth. That's the issue, because there will be no density change if it's along the same layer. You know what I mean?
But it is, because the Earth is curved. It will find itself as an elevation as the Earth curves.
No. Let's just say that eyeball that you drew, you put that on the ground.
What? You want me to put this? You want me to move this down here?
The eyeball.
Okay.
On the left.
Hold on. Okay. Give me a second to go. I have to go. Right. So you want me to move? Oh, God.
All I'm saying is you don't even have to change anything. All I'm saying is I think our whole point is, I don't want to speak for other people, but that light ray has absolutely no intrinsic desire to curve around the Earth going through a constant medium. It does not. That doesn't make sense, man.
Well, that's what the light ray
doesn't.
Can I ask you a question?
That's what the laser did. That's what the laser did.
No, but Rumpus, it's going through the same medium because there's no elevation change.
There is. I'm just showing it to you. Jesus.
No, I'm saying put the eye down towards the Earth. Move it down so the observer is right against the Earth.
Light comes from the lighthouse, mind of God.
Yes,
what the observer
let's say
is relevant.
Right. Let's say the observer is not. Let's say there's no elevation change and the observer is down.
Then it would follow a straight line.
Mind of God,
it would follow a straight line. Mind of God.
Yeah, no, Brenda. Yes, you're correct. That's our point. It would follow a straight line. Absolutely.
Yeah, so you would see it.
No, it would follow a straight line.
Go above your head.
Yeah, exactly. It would
follow a straight line, and then it would emerge and intermerge.
I'll do it again.
It's subject.
No, Brenda just proved the flat Earth. I'm good now, so that's fine. We can move on.
That didn't prove flat Earth.
You just said it would travel in a straight line.
It proves, Brenda, that
Adam, you had a question.
The full holographic image in the way that they're pretending. It's absolute
is not
proof of that.
This is not a holographic image.
Well, let me just ask the question. Because what I'd like to ask is,
Adam, repeat.
is the light beam rumpus at the top of the lighthouse subject to the same atmospheric changing conditions over the distance as the light beam at the bottom of the lighthouse?
Correct.
Is it?
No.
Well, the ratio
is the density, as you've suggested, to portray the difference between 1 centimeter and 2 centimeters on any there, a continuous changing graduation to allow a 7/6R to give you the assumptive bendings you're doing. So I'll ask the question again: is it the same at the bottom and the top of the lighthouse?
The thing that causes it to bend is the change.
No, it's a simple yes, it is the same, or no, it isn't. Come on.
It's same in one way and it's different in another. And if you let me
same
explain,
in one way, but different.
Yeah, that's funny, isn't it, Adam? Oh, you're really good.
You're having it,
you little funny twat, aren't you?
Right, okay. Hang on.
Can I be allowed to answer his question? Hold on. I would like to answer Adam's question properly.
Okay, well, go ahead. Go ahead.
Francie, please let me answer his question.
Go ahead.
I'd love you to answer my question.
So if you just don't interrupt me after 2 words into my answer, you'll understand.
They're just winding you up.
Oh my God! Yeah, I know he's being a twat. We know he's a twat. We all know this. So I accept this is happening. Right. So there is a difference. For instance, density down here.
With your religious beliefs.
Adam, you twat. Let's stop it. Stop behaving like a little twat.
They're facts, aren't they?
Stop behaving like a little twat. Right. So down
a little
here,
twat now.
You're a little twat.
A little. Oh, I hurt so much.
Have one density,
stones.
And up here.
Come on, guys.
So here we have 2 different.
I don't know what a twat was if you hit it in your face. You've probably not seen one.
So, you're not interested in the answer, are you? So here we go.
Yeah, but I'm interested in the answer to my question,
Adam,
not the superfluous waffle you're about to give.
But you're not letting me because you're a twat.
No,
so here we go.
I'm not letting
Here's
you.
the answer.
Here's
the answer to your
you're
question.
You're going to give a load of superfluous.
Here's the answer to your question. There is a different density between this point and that point. So the density is indeed different. But what causes refraction is the density change. So in other words...
Wait, Rumpus, which 2 points?
No,
which
just
2 points?
please let me finish my goddamn sentence.
Can't take him.
Right, here we go.
All right,
for the density change, in other words, the gradient...
There's a difference then, Rumpus.
Hopefully... I know you don't want me to...
There's a difference in the... Rumpus, there is a difference in the starting point and the densities of the path that each beam will follow.
Stop
trying
to give me an answer.
Is that
Stop
correct?
Trying to prevent me from giving an answer.
There is a difference.
Francie, can you stop him?
Each path will be subject to a very different set of mediums.
Okay.
Is that correct?
No, I want to give an answer.
Right, well, I'll tell you, here's how we're going to do it. Rumpus.
With individual density difference.
Here's how I want to do it. I want to do Rumpus first, let him respond, and then Adam, you can respond afterwards. Then, yeah. So let him dig his hole first.
Yeah. See, he's incapable of behaving like an adult. So right, here we go. So when there is a difference between the base of the lighthouse and the top of the lighthouse in density, the density of the air is much greater at the base of the lighthouse. Well, much, but relatively is a difference, and there's at the top of the house, it's less dense. But what causes bending is the density gradient, and the density gradient here, in other words, in mind of God hopefully understands that the differential is the same. The difference between going up by an inch is the same as going up by an inch here, or very, very similar. So that means, and that's what causes the bending. It's not the absolute density. For instance, light will go in a straight line through glass. It won't bend, even though it's much denser than air, because there's no density gradient in a slab of glass. It's all the same density. What causes bending is a density gradient. So at the bottom of the lighthouse and the top of the lighthouse, it is the same in terms of density gradient. But what Adam was trying to point out, I think, was that the density of the air is different. Yes, but it's the same density gradient, which is the thing that causes refraction. Finished.
Okay, Adam, your response.
And then me next.
Oh no, come on, I'm waiting on something here.
You're confirming, Rumpus, that from the bottom of the lighthouse to the top of the lighthouse, or from the bottom of a mountain to the top of a mountain, that the cumulative differential density gradient is always the same to ensure that an image renders as if it was on a flat plane. That's what you seem to have just described to me. If that's your statement, I'll accept your statement.
So you now understand that the top and the bottom of the lighthouse have the same density gradient, even though they've got different densities. Do you understand that?
Even though their paths from their initial inception, where they're in a different medium, as you would suggest, you're suggesting that even though they start in different mediums and traverse at different rates, because the bottom one is obviously subjected to R plus its height above R. The top is R plus the height above, yeah, which is greater. So it's a different arc value as well.
No, the arc's
the same. What you're suggesting is that both of these positions will always, no matter what height the object you're looking at, and no matter what distance you're viewing it at, they will always render to give the image of a flat plane.
No,
none of that was even close to the truth.
That seems to be what Rumpus is describing.
Let me just try again.
I don't know how you got that.
I obviously didn't do a
White knighting.
Okay, right.
I obviously didn't do a very good job.
I don't want to hear it again, the Rumpus, honestly. No, I don't want to. I honestly don't want to hear it again.
Yeah, no, but did you? Okay, Randy, but did you understand? I want to.
Yeah, I want to.
Randy, I would like to know. Did you understand what I said?
I heard what you said. I heard what you said.
Because you're stupid.
Now then, can I want to present something too, so if you can just, and then Tony wants to have a go, so just give me...
You're stupid, you didn't understand what I said. Okay, we'll go with that.
Just give me a moment to have a look at this. Right, so I looked at your image for this ray tracing that you've done, and what I'm looking at here is I'm looking at, obviously, this is the laser beam, and this is it fucking off.
This is for an inferior mirage. This is completely different circumstances to what I'm not They're not the same, Ranty. They're different circumstances.
This is the image you brought up, and this is the image. I know
to demonstrate light was bending, not that it was relevant to my lighthouse example.
Yes, and I'm just saying that the light is bending in this direction. So, hold on! And listen to the point. Listen to the point. Is it because this is so devastating?
They're different situations.
In all, right? Okay.
Let them finish, man. You do.
So,
talk your
in all of your ray tracing, in every single one, the arc is always downwards and more or less perpendicular to the shape of the Earth downwards. Even though it's going up, it's still coming down. You never show this.
No, I do. Okay, Ranty, I'll show you.
You never show this.
I'll show you that. I'll show you, and I'll show you. You twat.
On this image here, we are not seeing this. Now, if you've got something else to share, by all means.
You're a twat, Ranty. I specifically told you those were different circumstances. On Lake Balaton there, it was warmer at the base, and you claim I've never shown you going up. You didn't listen
I didn't say that you had never shown me. I said that in the image that you're presenting here.
Yeah, I didn't claim was the same as the normal standard atmospheric refraction. That one's got in real world. You see, the thing about standard refraction, it's a simplified version of the real world. In real life, in real life, we have these inferior mirages, which are caused by the ground, say the road, getting hotter, which means it doesn't conform to the lighthouse diagram that I just showed you. There, and I spent an hour with you.
I know. I've seen your ray tracing. I've seen your ray tracing diagram.
Hold on,
90 minutes.
Shown you with light going up. Well, God damn it. That's what I showed you here. You didn't understand this pink line that I went at. We spent about a quarter of an hour on. There it is. It goes down and it bends up just like the Lake Balaton line. That's bending up from the surface of the Earth. And we spent a quarter of an hour, 20 minutes on this particular ray. But you didn't understand a word, did you? Because you never listen. You never understand. You're too stupid, too ignorant. You never listen.
Look at that ray tracing. Look at it.
He fell right into that.
Just so it works. But he's just previously just described, Anthony, as an apologetic how that picture over Lake Balaton bends it to that degree just by a small slight inversion of over the ice to the land. Yet all of it renders perfectly all the time, you know. Doesn't matter the height of the object, the distance to the object, because Rumpus can pull out a picture with lines on it.
Yeah.
That means it's a ball. What a fool you are, man. You're delusional to yourself, mate.
I've got a question, Rumpus.
Hold on, I just want to show a little picture.
You just go on and on.
Yeah,
you're not going to help yourself,
stupid.
are you?
I have to explain to a
just
stupid
proving our point. Brilliant.
Okay, so you're denying then what
I'm denying, mate. I'm denying that you have any comprehension of what you're talking about.
Moron, and
I'll say that.
So here we have an inferior mirage.
See what I mean? You can't even do a decently structured ad hoc.
Here we go.
You see how I might
have we have an inferior mirage.
Some intelligence.
And there the light is bending up when it's
a
near
little
the ground.
bit of
Can we all see this? Can we all see this object here?
Shows the level of
you should be able to see that there's an inferior mirage. That is caused by the Lake Balaton type bending. It's not part of standard refraction. It's a special case. There are 4 or 5 special cases you have to consider, and this is caused by the light bending up as per Lake Balaton. This is not part of the standard refraction that I was showing you in the lighthouse. There are numerous different situations you have to deal with. I know that Adam can only cope with one concept at a time, but unfortunately, in the line of refraction, there are many different complicated situations you have to deal with. And I know I'm describing several of them, and you can't distinguish between them because you're stupid, and Ranty didn't understand any of them. I appreciate that. But this is the situation. There are different situations.
I'd just like to thank you then, Rumpus, for pointing that out to me, because that's a very useful thing. I'll try and work on that.
What, your stupidity?
Rumpus. Go back to your picture with the lighthouse on it. You know the diagram. I'm just curious about one of the labels that you've got on the picture. Yeah. So it says where the boat is in the middle. It says you've got an arrow. No. Where are you going?
2 sets of it, and one we were looking at had the perceived. I don't know whether that one would do. Hold on, I've got another. I've got it in 2 places. So were you looking at the other one? Hold on, give me a second.
Okay. Yeah, that one. That one's fine.
Do you want one with the image in here as well?
No, it's okay. Just stop.
Oh, let's go to the simplified one. Okay, we'll go to this one. It's simpler to look at.
Okay, the boat. You've got an arrow, a black arrow that leads to the boat, and it's labelled geometric horizon.
Correct.
We don't actually see a geometric horizon. We only ever see an apparent horizon. Correct. But on your diagram, the apparent horizon will be obscured by a geometric horizon that we can't see.
Well, no, the geometric horizon has no meaning when you've got curved light. What does it mean? It means nothing.
But we don't see a geometric horizon.
Correct. We don't.
So how would we know it? How would we know it's there?
Hold on, you don't. So Anthony, here, look at this diagram here. This is what you would see in this situation here. So we've got the boat on the geometric horizon. We've got just so happens I've drawn the base of the lighthouse on the apparent horizon, and this is what you would see in real life.
So the horizon. Wait a minute. So the horizon.
Jesus, can I just? I've got 5 more seconds, please, and I'll stop.
There will be a point. Obviously,
can you just give me 5 more seconds, please? And then you can make whatever point you want to make. Hold on. So here we go. On the left.
7/6
on the left of this diagram. On the left here. On the left is the unrefracted, no refraction situation. And over on the right-hand side, we have the looming. And as you can see, on this situation, the boat is on the geometric horizon. And over here, you have the horizon loomed up along with the lighthouse and along with the boat. The boat no longer appears to be where the geometric horizon is. You can't tell the geometric horizon. There's no way of perceiving. Oh, just nearly finished. Really, 2 more seconds. You cannot perceive the geometric. You're right, Anthony. You cannot actually perceive the geometric horizon when there's looming, when the light is being bent. There's nothing about it that's special at all. It ceases to have any value in the picture. There's nothing special about it. You can't see it.
But, you know, looming, it's defined as being with respect to the horizon, not including the horizon.
No, looming's everything.
It's not. It doesn't include the horizon. It's only things that are supposedly behind the horizon.
Okay, Anthony, I've got a quote for you from... Let me just show...
Yeah, we did this. Andrew Thomas Young.
Yeah, from Andrew Thomas Young. I've got a... Why the...
Because I'd like to focus on the bit that we didn't get to.
I've got a very interesting quote for you.
Where does 7/6 become 6/6, Rumper?
Didn't.
Well, it must do. You've just said it did at some point. Look, on your pictures there. Where does 7/6 become...
Here we go, Anthony. Would you like to read this here?
I'd like you to read it from the webpage itself.
It's from the website. Okay, I'll go and get it from the webpage. Okay, that's a reasonable request. You have to go and bloody change...
Because I know where it is on the website, you see. I saw it the other day, but I think you got kicked.
Right, let me just...
Rumpus, are you sure it's a ball, man? Are you 100% sure, buddy?
227% sure.
200, okay, just checking. I'll go on.
Shows you how good he is at maths.
Yeah, you do realise there's only 100%.
Yeah, you can't have 101%.
Yeah, I was having a bit of a joke there. I was being a bit of a devil.
Oh, I don't know.
I think that's this right window. Is that actually the right bloody thing?
Yeah, there we go. Excellent.
Right, could you please, Anthony, read... I got the right bloody...
Yeah, you are. Just scroll up a bit.
No, hold on. I seem to have lost it.
No, it's at the top. It's at the top.
Hold on. Did I just lose what I was... Is this the right page, Mr...
Yeah, stop there. Stop there.
Stop there.
There we go. Here we go. Yeah, sorry, this one here. Yes. Location. Yes. So could you read...
Rumpus, Anthony knows what lies he's telling.
Does he? I'm not so sure. He's too stupid, I think. Right, Anthony, if you could read from there to there, I would really appreciate it. Can you see
It is incorrect.
Sorry to interrupt you. There you go.
It is incorrect to say that a mirage is an image in the wrong place, because atmospheric refraction displaces almost everything we see from its geometric position. That is, rays of light in the lower atmosphere are usually curved because the density of air usually decreases steadily with increasing height. Well, we know it curves...
Could you just finish off this last bit, please?
Thus, everything normally appears displaced slightly above its geometric or true position. This displacement is known as terrestrial refraction when the object is inside the atmosphere, and astronomical refraction when it is beyond the atmosphere.
So do you see that? Thus, everything, and that includes everything that's on the horizon, normally appears displaced slightly above its geometrical true position. That everything includes the horizon, because the horizon is just the collection of objects that are on the horizon. So everything is displaced above its geometrical true position, as I demonstrated in that diagram.
As I mathematically stated to you earlier, with any transit of the light, that is mathematically impossible for it to then render as if the image is a flat plane. That's the point we're trying to make to you, Rumpus. For you to pretend that this statement means that things render as if we are viewing things with perspective only on a flat plane, from it being actually in reality a curved ball, is just ludicrous. It's ludicrous, mate.
Rumpus, could you go back to that page? You went off it before. I wanted to respond.
Well, I've got the same quote. You should be able to recognise the same. If you look at,
it's not just the quote. He wanted to go back over a point on that particular citation that you brought.
Yeah, but let's just deal with this quote first.
No.
Yes. I know it's uncomfortable for you, Ranty, but
it's not uncomfortable to me because I'm not debating you. But I just heard that Tony had said, because he asked you to bring that up, and then you asked him to quote that. and then he wanted to actually respond by saying what he originally wanted to talk about.
Okay.
Yeah. Go to the top of the page if you would.
Let me go back and rescreen the.
If you could go.
I'm just too nice is my problem. That's my. I'm too indulgent.
Have you ever seen Scrooge?
Yes.
Where he goes, I'm I'm too kind.
Top, please. Rumpus, top.
But in my case, it's true.
Top, please, Rumpus.
An introduction to Mirages is this page.
Oh, hang on a sec.
Yeah, I knew you wouldn't know it was the right page.
Yeah. Would you mind going to the other page that is often cited? I'm not sure where this is in his site.
It's the one on Looming. I think you're trying to get to, isn't it?
It's the one that starts off with the paragraph identified as refraction.
I think it's just Looming.
That one there. Mirages are distinguished from other.
Mirages are distinguished from other refractions such as looming, visibility of distant objects hidden below the apparent horizon, visibility of, you see, there you go, and towering, which is an exaggerated version of that, and sinking and stooping, yeah? Okay.
No.
So what do you want?
Click on refraction phenomena.
The page you want is looming. Hold on, I've got it in my bloody bookmarks. Hold on a second.
Whilst you're at it, just one question. Whilst you're looking for that, could you just remind us about an inferior mirage? Did you say that inferior mirages over water are unlikely to happen if they were flat?
They are less likely than much less likely than on a curve, yes. And I know you found a quote by some person describing water as flat, but that you're a twat. I know. A local form of flat, and you don't understand. We had a hangout about this about 2 weeks ago, where I described to you flat is curved. Flat is curved because
it's not, though, is it, really?
Form of flat means that it is curved, and you didn't understand that, did you, Ranty? And so when people talk about the flat salt, the Bolivian salt flats, it's the colloquial form of flat, but it means it's actually curved.
It's flat, not though, is it? Flat is flat.
Come on, man. No way. What are you saying, man?
It's very simple. It's a colloquialism.
So why didn't they say when I type in inferior mirage in Google, why didn't it say that it can sometimes be seen over lakes or oceans since these surfaces are very extended and curved? Why didn't it say that?
Because it's a colloquialism to refer to flat things as just following the flatness of the Earth, which is in fact curved. You're a twat, Ranty. Right, you don't understand this. If we can go to the definition of flat, if you like, I think which actually describes this exactly. The use of the word flat.
Hang on, let's do that in a minute.
I've got to deal with an idiot, I'm afraid.
That's not an idiot, mate. That's just totally owned.
No, you're an idiot. You're an idiot. It's what's meant by flat? No.
So flat means curved, right?
It does indeed on the Earth. Yes, we refer to things like the Bolivian
like hearing
flats.
So hang on a minute.
Well, hang on a minute. Level, horizontal, leveled, smooth, uniform. The uniform. What does uniform mean? Don't go off of that. Don't go off of that.
Hang on, Ranty. If flat means
what does uniform mean? No, I'm reading the citation.
Ranty, listen. If flat means curved, doesn't that mean that the ball actually is flat?
Yes, correct.
Yes.
Yeah, we could use that. Yeah, exactly.
So it's actually an argument of equivalence, Rumpus.
Keep looking.
Can't quite. There's a very good definition where it goes into the.
Unfortunately, you just can't find a definition that says flat is curved.
When I do, then Ranty, you'll accept it, will you? That's sorted you out, didn't it? So when I go and find it, you're going to have to take it back, aren't you?
I'm seeing it now.
Well, yeah, we know that. You're a stupid moron. We've been through this. We've actually shown you this definition. I'm sure it's to you or Anthony, where we've got the word flat and the definition is used, and it's used colloquially to mean, in fact, it just looks like as a large flat space, but in fact, it's flat. It's
level
curved.
and smooth with no curved high or
So why are you
hollow
so
point.
triggered when we say the Earth is flat? You just proved that it is flat. It's just curved.
Well,
is it at
Why
the
are you
top
so
there?
frustrated?
Different meaning. You don't mean when you're not using the word flat as they did in the quote that Rant is trying to provide. You mean actually you actually mean really flat. You're not going to use the colloquial term like in salt flats. You actually mean it's a plane. Now
Okay,
that's
so we believe it's really flat. You believe it's flat, right?
Okay, so I've got it up on screen for everyone to see. So it says level, horizontal, leveled, smooth, even, uniform. Nowhere does it say curved.
Where's that one you've got? Is that which dictionary is that?
That's just flat definition. The
Where?
first
The
result.
Dictionary Cambridge one, Ranty, look. No curved. Level and smooth with no curved or high parts.
Where's that from? The Cambridge, did you say?
Yeah, the second one, yeah.
So you want me to open that one up?
It's the one that gives very good.
Dictionarycambridge.org.
It literally says it.
With no curved.
It literally says it there, with no curved.
Yeah,
high or hollow parts.
colloquialism, unfortunately.
So flat can't be curved then, can it, Rumpus?
There's a it is used, unfortunately, by idiots in a sort of colloquialism to mean, in fact, it's not. They can't perceive something's not. It means no mountains on it. There are no mountains, and obviously water.
Rumpus, say colloquial 3 times in a row. Say it 3 times, quick, for the audience.
That's right. I think I've said it enough. Thank you.
Okay.
There's one of these definitions.
Just say curved is flat once more for me, just because I love hearing you say it.
Flat is curved.
Say it. Go on,
If flat is curved, that also means curved is flat.
No, it doesn't, because what you don't understand, Anthony,
and it does. If flat is curved,
don't understand that words have multiple meanings.
Words have meanings.
Words have multiple meanings, no less.
Yeah, they do, but they don't mean the opposite. So red doesn't mean blue, right? Curved doesn't mean flat.
Okay, so let me look. Well, let me look at what curved looks like in the same dictionary, right? So I've not.
I bet it comes back and says
not flat.
Yeah. That would be hilarious.
But it's used to mean not having any mountains on it. That's not.
No, it's what you use it to mean to support your religious viewpoint, is what you say.
How can I be religious? Are you religious, Adam?
No, not in the slightest.
So why? So to believe in a religion, you've got to believe
that
in
bums you, didn't it, Rumpus?
So you've got to believe in a supernatural being. So you see, that means you're claiming that I believe in a supernatural being has got ultimate control and created the universe.
No, I said your viewpoint is religious. It's not based in any real fundamentals.
Every single thing I've demonstrated today has been backed up by science. You don't even understand.
No, that's false. That's false.
Everything I've demonstrated today has been based on science. You are a science denier.
Brenda just proved the flat earth. Brenda proved
you're a science denier. You are a science denier. You've demonstrated many times you don't understand science.
I deny that light
you have demonstrated many times that you do not understand anything about science, and you're a science denier.
Science denier.
We don't accept your cartoons, man. We don't accept your cartoons, and like that's.
Well, you're a religious nutter, mind of God. I mean, if there's evidence that can't count as your religious point.
Don't stop your projection, Rumpus. On somebody else.
No, he admits it, D. Adam, he admits
you're not religious.
Adam, he admits it. There's no point. I'm not making a charge against him. Anything he can deny.
But Rumpus, there's parallels. There's parallels.
Decided to go on that route as opposed to deal with the accusation to you.
Well, it's a ridiculous accusation.
You tried to level it at me, and then I said, "No, I'm not."
I mean, I'm just wondering why you're such an idiot. I can't. I mean, you're so stupid.
You quickly jumped on somebody else.
You keep on claiming you're doing something at universities or something. I don't know whether this is in science or in cleaning the floor, but so either you must have a religious.
You projected again.
You must have a religious.
Trolls pretend to be stupid.
In the lab of the
Trolls pretend.
Trolls pretend. Your face is just in light rays curving, and they don't.
I think he's just genuinely stupid. I don't think he's trolling.
Your faith is in something that is not real, so it is similar.
No, it's not faith. I could base everything I do in maths and science is backed up and peer reviewed.
Okay, Rumpus, what does 2A say there? What does 2A say? Having a continuous horizontal surface.
It's one meaning of flat, yes.
What does it's not curved though, is it?
Can you see all these different definitions, Ranty? Look at them. There are 12.
And never does it say curved. Yeah, and never does it say curved.
They're 14. They're of a sail. Oh no, it's not. When you say it's flat, you mean of a sail. Oh right. So that's what you mean. You mean
the sail is flat,
no,
isn't it?
Sail, Ranty. When you say flat, you mean a sail. Oh, so I've proved it by showing you this definition in here.
You just don't understand the English language.
I mean, I know you're stupid, Ranty, but even you must realise that words have multiple meanings, and sometimes they feel multiple meanings.
I don't think they're that stupid. They're just having a go at you.
No, I think they are that stupid, Brendas. Really, I mean, we've got Anthony here who claims that light doesn't bend. We've got Adam here.
It doesn't bend, Rumpus. Everybody knows light travels in straight path.
You see, there we go. I mean, I don't know. Do you really believe that, Adam?
Don't you?
We know that.
Do you really believe what you just said, or was that
Don't
just a
you,
troll?
Rumpus?
Hold on, I'm asking you a question first.
I'm asking you one.
Yeah, no, and then I will answer your
Don't
question.
you? I made a definitive statement.
Well, I know, but I want
you a bit
I want
thick
to know
and
if
didn't
you
hear what I said.
Yeah, but
You'd like to try and turn it round, but
vis-a-vis
vis-a-vis your programming and the way you express things.
But I want to know if
I'm
you're
asking
serious.
you, Rumpus.
I'm asking if you were joking.
Rumpus.
I'm asking if you were joking.
Yeah, but I'm asking you, Rumpus. Don't you?
You made a statement, and then I asked you a question. Could you please answer my question?
I made a statement, so you shouldn't then need to ask me the same question.
I do, because you could be joking.
Should you?
Be joking.
Unless
you know the answer. You know the answer. He just said it.
I want to know if you're joking.
I don't really know, Rumpus.
Are you
Rumpus,
joking?
You guys assume straight rays when you do the far field approximation with the sticks in the ground. You believe light rays go straight, not us.
Right. Mind of God, do you understand that as the light comes from a high altitude, a high elevation, it's not refracted, so it does travel in straight lines? Do you understand that?
Okay, but why are you giving him such a hard time when you just disproved the fact that light does in some cases travel in the straight line, correct?
It does sometimes travel in a straight line, but
so why are you giving us such a hard time when we believe that?
He seems to think it never does. It never goes in a bend. I want
no
to know
one said that. Now you're strong.
Actually, that's what he said.
That is what he said. You ask him, mind of God. Mind of God,
no one would ever say that light
God,
could
ask
never.
him yourself.
He just said it.
Ask him, mind of God. Would you please ask Adam that question then?
1 second after I finish the statement. Our issue is that light never has an inherent desire to travel around Earth curve, concentric with Earth curves, naturally.
Now ask Adam the question.
Well, Adam, do you believe that under all circumstances, light never has the ability to change direction?
I think there's always. I'll change direction.
Yeah, in some cases, can light change direction?
The question was bending. Mind of God, the question was about bending.
Of course, light changes direction.
That's what trolls do.
Ask about mind of God, we didn't ask about reflection, which is a change of direction. I asked about bending, and you changed it, you twat.
Well, of course, because he's a troll.
Why'd you show us that green thing change direction and say that's curve?
Mind of God, will you please ask him if light bends?
Under what circumstances? Just so I ask him clearly.
He's a troll.
Ask Adam whether or not light can bend.
Can bend.
Yes.
Yeah. Adam, do you believe that it can under certain conditions?
Well, maybe Rumpus could describe those conditions to me.
Correct. Yeah, let's hear that. To go back to that image, you didn't answer my question, by the way. With that eyeball on the ground, why didn't you show us?
I'm happy to deal with that eyeball on the ground.
Yeah, okay. Because that ray is not going through a different medium. What is its intrinsic desire to curve?
You didn't understand, did you?
Go back to the PDF. How many pages is that thing, by the way, now?
God, you're stupid.
You had a hurt shoulder. You had a cough. When are you publishing that so we can make fun of it?
Oh, I hope to do it quite soon. Actually, I'm working on it again. I haven't been working on it very much.
Under standard diffraction, mind of God, the light rays coming from the base of the lighthouse would follow the curvature of the Earth.
Did you say diffraction, Brenda? Under standard refraction or diffraction? Sorry, what did you just say?
I don't remember. So I might have said diffraction, but I meant refraction.
Okay.
Under standard refraction, light from the base of the lighthouse would be following the curvature of the Earth, because anytime it started to deviate upwards, it would get bent back down.
No, that's not true.
No, that's not true.
So.
Understand
was I accurate there, Rumpus?
Sorry, Brenda, I was too busy collecting this.
Standard refraction would bend light down.
Correct. As in, I'd drawn for the lighthouses thing.
That's not what you just said. You said under standard refraction, light would follow the curvature of the Earth.
Same thing.
That's not true. No, it's not. No.
True.
No. At standard refraction on your model, standard refraction is 7/6, not 6/6.
Yeah.
So it doesn't follow the curvature of the Earth.
Yeah, but it approximates, so it goes towards the Earth. It does what I've got in this diagram. In other words, it creates a curve which sort of follows it. It doesn't go exactly as tight. It doesn't go as, hold on, let me finish. It doesn't go as tight as the curve. It doesn't have the same radius of the Earth, but the 7/6R still bends in a way that means it sort of follows the curve of the Earth, but it's not tight enough to keep track with it. When it is tight enough to keep track with it, then it's got called circulating rays, and then you can see your own bottom in theory.
Rumpus, for that to be true.
That would only be near a black hole, though.
Hang on.
No, it's not actually. It's not.
You could see
Tightness
in a
seeing it.
black.
Hang on, wait a
if you were
minute.
in-
Tightness
if
seeing
you
your
were
own
in a
arse in a black hole. Come on, guys.
So
Right.
here we go.
Come on.
Well, yes, that is
Here
funny,
are the
but
K
Trolling now,
values.
man. Come
Right, so
on.
here are the
if you were in the influence of a black hole, you could see the back of your head, right?
But it's also true in theory, although obviously you can't because of the attenuation, the fact you get mountains in the way. But these are the potential bendy rays. These are the options. 0.14 I've got here is the 7/6R bend. And as you can see, it doesn't bend as tightly as the Earth does, but nonetheless, it still sort of bends around the Earth to some degree, as I demonstrated in that lighthouse
Compass
diagram.
seems like a really valuable resource. I don't know why you haven't published it, because it would be really valuable.
Yeah,
His shoulder's been hurting for 3 years now.
it is quite good actually. Yes, and I will be publishing it shortly. There's a lot.
It looks a little bit like a backworking of how shit would have to be if you were on the ball, based on an image of a flat plane that we live on.
I didn't hear what you said, but I don't care.
Rumpus, I'm concerned about the surface ray.
I
man.
don't
Walk-
care.
Okay, you want to go?
Just going to do a massive shout out to Godzilla37, who says, Brenda, for fuck's sake, you were done years ago. Give it up already. Thanks for smashing the super chat.
The bottom ray here of this lighthouse and what it does. Okay, let's deal with that.
Absolutely.
Okay.
And Brenda said earlier that it's going to go straight, and that's true. That's
Right.
what it
Let's start off. Let's start off the little history of this light ray then. So we've said the light ray is going to be launched at tangent to the Earth. So it's going to follow this bit here.
Yep.
So it's going to find itself, because it's following the tangent to the Earth, and because the Earth bends away in its drop, it's going to find itself in effect going upwards, and therefore it will find itself higher up above the Earth, which means it'll have a lower density air around it than it had before, which means it will now start to follow the same ray that the top of the lighthouse did, because there's more dense air below it and there's less dense air above it. And following the rule from the laser in the tank, things bend towards the greater density air, which means it'll bend to the left and it'll bend towards the Earth, just like the laser tank did. And
Is the density differential the same for the light beam travelling at the top and at the bottom?
very similar.
Very similar. So not the same,
I
then.
explained this to you about 20 minutes ago.
Yeah.
So again,
So very similar is not the same, yeah. Just to
well,
clarify that.
the gradient is very slightly different.
Not the same, Rumpus,
It's effectively the same.
So not the same.
It's effectively the same.
Not the same then.
It's effectively the
They're
same.
different.
Very slightly.
In other words, they are not equal to each
They
other.
can be treated as the
Yeah,
same.
unequal.
They can be treated as the
Different
same.
values.
They can be
have to-
treated
So
as the
Rumpus,
same.
if your point
For all
is that it's
practical
going.
purposes, they are the
If you were
same.
typing them into Excel, would you type the same digits in?
If you did it 3 decimal places, yes.
If you did it to 4,
Yes.
4 have an effect of 5.
Yes.
Well, the atmosphere is exactly the same to 5 decimal
No,
places.
you asked me
at
about the differential.
Light
not the
house
same.
than
No,
it is
you
at the-
asked me about the
Is that-
differential, you
is that a
twat.
statement
You've
of
now
fact?
changed. You've
Is
now changed
the
the question.
lighthouse
You asked me
atmosphere
about the
at the top
differential, and now you're
changed
changing it to
in
the
at the bottom?
density.
5 decimal places? Rumpus?
Adam,
The
he's talking about the
differential-
derivative of that curve.
Yeah,
He's talking about the
exactly.
derivative of that
I don't
profile.
think he knows what a differential is.
Please.
Adam,
I
just
don't
wait,
think
just wait.
he
Let me
knows
finish
what
this point.
differential
When you
I don't
analyze
think-
any of it,
Adam, do you know what calculus is?
Just
Do you
wait,
know
just
what
wait,
calculus is,
Adam.
Adam?
He's talking about the derivative of that profile.
Yeah, he
Don't
doesn't
worry.
understand that. Mind of God, he doesn't
I
understand.
do understand it. I'm asking about the input parameters and the pathway that each individual photon would travel. The one at the top and the one at the bottom. And I'm asking about its transit, yeah, for each individual one and the differential in its transit and how that differential in its transit tends to render to a perfect image.
He's saying it's similar because the height of the thing is negligible. So
You're
it's
saying
gonna,
it's different then.
He doesn't understand differential, I'm afraid, mind of God. He doesn't understand what I'm talking
Differential.
about.
I'm asking for the applied differential.
The
of
applied
distance
differential.
based upon the differential between the top and the bottom. All of those factors come into play, Rumpus, don't they?
No, the only thing that matters.
Oh, all right.
The only thing that matters is the differential, the change in density between one spot and another. It doesn't matter what the
Fine,
absolute. You see, you interrupted me. You don't let me finish. You don't. Right, here we go. Let's try it again. The differential, and you probably don't know what I mean by that. That means that the gradient of the density here is the same as the
I'm
gradient.
asking you, is that exactly the same when applied over the distance?
The distance of what?
You were talking about a differential of bending, yeah, in terms of the density differentials, yeah?
Yeah.
So I'm saying to you, is that exactly the same for the top and the bottom? And
As close.
The paths that both of the great follow.
And when I told you yes last time, you then said, "Oh, are you saying that the atmosphere is the same as one as the other?"
Because as you admit, there's a differential in the atmosphere as you go up, as you've just described.
So you don't understand.
Which is the reason that the bottom,
you've just demonstrated. About 20 minutes ago, I explained to you. 20 minutes ago, I explained to you that the gradient of the density is what causes refraction. The gradient, not the absolute value. Just like I talked about glass, you can still have light traveling through glass in a straight line. And then you said, is it the same at the bottom and the top? And then you said, you said the densities would be different. But what you don't understand is it's the density gradient that determines the refraction. It's the density.
Okay, listen, I have a question.
Those differentials always apply
to be. You don't understand what differentials are. You don't. Oh, you just from your answers, I can tell you what calculus is.
Saying is the net effect.
I can tell you don't know what calculus is. Same. Which means you do not have the education of a 16-year-old at
school. The way you're answering it is the way you're doing.
The fact you don't understand what I'm saying means you do not have the skills of a 16-year-old studying maths. That's why I don't think you're at university or doing anything remotely related to science, because you don't understand what calculus is. You're clearly an utter moron. Yes, Ranty, what are you saying? What's the question, Ranty?
The question is...
Mate, that's O level, like GCSE, beginning at GCSE, A level, isn't it? Rumpus, you're such a fool.
Okay.
You're
saying I'm wrong. You're saying you do understand.
It shows your level of educational insult.
Then. Okay, you're telling me I'm telling fibs about you. Okay, right.
Non-educated.
Okay, you're saying I'm being unfair to you. Okay, you're saying I'm being unfair to you.
You're trying to pretend you're something you're not, mate.
Right, okay.
Yeah?
So
I'm don't try and do that. Don't try and do that. I am what I am.
I'm being really, really unfair to you. Okay, let's see. Let's see. Okay, let's pose. Here's an equation for you. Here we go then.
Carry on.
Right, Anthony. So Adam, I'm being really unfair to you. It's a basic thing for a 16-year-old. You just said. Could you please tell me what the differential of that is, please?
Yeah. dy by dx equals 2x.
My God, he does know something about it. Jesus Christ.
Fuck you, asshole. I'll never bring my face again. Shove it up your ass. Admit your humility, you fucking turkey.
So in which case then, you've got absolutely no excuse for not...
I'm never ever going to humour you on that again, you fucking turkey.
So in which case you've got no excuse then for not understanding what I said here about the differential...
Do you realise, you fucking imbecile, how stupid you just looked?
No, I didn't at all. No, you're a twat. You're a twat. I mean, okay.
All right, guys, don't, Rumpus, don't do the quiz, man. Let's move on, man. Let's move on, man. We're good. Don't belabor this.
Come on here with you.
So anyway, had I answered your question satisfactorily?
Show me up on fucking shit. You're a turkey, mate. You're an absolute
then. Okay, you're so clever then.
You threw that insult at me to distract away from the point I'm making. Now I'm going to be done.
He did say he wasn't going to do any more of these.
Tell me what the differential of that is then. You're so clever, Adam.
Mate, you're never getting anywhere else again.
Tell me what the differential of that is.
You absolute moron.
Come on then.
He did say he wasn't going to do any more.
I don't need to do you again. You fool.
You can't do.
Don't need to, do I?
I gave you
doesn't matter what you throw at me now,
I gave you the simplest.
Did you, mate?
I gave you
turned you over,
question
slapped you on the arse,
ever asked.
Made you look a fool on YouTube,
something
didn't I?
that a 15-year-old would be expected to do.
You can try and undo. You can try and double up, but it doesn't matter, does it?
I gave you the
Rumpus. Minus x to the -2, man. Let's move on. We're good. We got it, man. Don't worry. It's good. We know derivatives, man. You don't need to.
Yeah, well, he doesn't. He got the simplest one. I presume but he wouldn't be able to do anything more complicated than that. Anyway, so
where's your validation there, Rumpus?
That's you wouldn't be able to do that, would you?
Undid every bit of assertion you tried to make. You're a fool, man.
You couldn't do this, could you?
Oh, look at you.
You couldn't do this.
Look at you. What are you frantically typing on Google to come up with another one? You're an idiot.
Couldn't do this. This is
an absolute idiot. You saw me do it in real time. You buffoon.
You can't do
You
this,
couldn't
can
do it
you,
in real
Adam?
time. You couldn't. You do like a Brenda. Oh, sorry.
This, can you?
I've got mute to hold.
You
button.
can't
Let's
do
just
this,
check it.
can you,
Let's
Adam?
just
Because
check
you're
it.
stupid
Oh,
and ill-educated.
connection problems.
Listen, you can't try and claim a victory out of this, the Rumpus. You asked him a question and he completely owned you. So game over with that, mate. I'm sorry, but
simplest differential question.
Let it go, Rumpus. It's
he
just ego.
doesn't need to
Hello,
do.
everybody.
He doesn't need to answer any more questions. To be fair on that.
He's an idiot.
No,
anyway, were you trying to ask me? We'll deal with idiot. Okay, we've dealt with idiot.
Okay, I've got one very quick
check,
question.
Randy, before you go.
Yeah, you're coming through fine there.
Hello, everyone. Sorry.
So, right, okay. So I'm just
told
going
you fucking bring a hammer, Brian, didn't I?
I know. I know, Adam. I didn't need it though. You were there.
What a fucking idiot he is, isn't he? He really is. And what I mean, nothing like doing yourself over, is he? What an absolute plonker. You plonker, Rumpus.
It's time to just concede. You know,
utter.
Right. So, when we're looking at these light rays here, which are obviously going from the lighthouse to the observer's eyeball, yeah, Rumpus, yeah.
Yep.
So the curving and changing direction, how many times? Thousands of times.
Well, they're following a curve, so yes, that's change direction. Yeah, repeatedly change direction. Yeah.
So how could you replicate that in an experiment? Would you be able to put? Would you be able to put like 100 different mirrors and just ever so slightly tilt them so that you change the image to go around all the way? Would that work?
Do it naturally. In the atmosphere, do it naturally.
No. If you was to try to replicate this using, could you replicate this using mirrors? Because it's incremental changes rather than a curve.
Yes,
you can replicate it by putting a pencil in a glass of water.
Right. So you could replicate it with mirrors,
right,
yeah.
Andy. No. Well done. You've actually. This is possibly the most intelligent thing you've ever said.
Okay. So what do you think?
Actually, all curves can be broken down into infinitely small little lines or little points. That's what curves, you can break them down into that. So in theory, what you're saying, if you had 1 billion little mirrors, you could emulate a curve, yes.
The problem with that is you would see an arc all the way to your eyeball from the observer of the different.
You wouldn't.
Yes, you would.
You've just said one of the most stupid things you've ever said.
No.
The observer.
No, you wouldn't.
Listen, Auntie, why are you being stupid? Well, I'll demonstrate why you're being stupid. You do not see this curve. All you see, all the photons that are going along this light ray, you just see one coming into your eye. You do not see the path they've taken. You only see it when
Hang on, did you say photons? Did you say photons? Hold on. Did you say photons? Did you say photons?
Hold on. Ranty, it's really important you understand this. You do not see the path the ray takes. You only see it when it arrives at your eye. You don't know how it got to your eye. It could have gone a wiggly shape all over the shop. You only perceive it as it hits your eye. You've no idea where it came from. Yeah, we know.
That's hilarious.
No, we do know where it came from.
You don't understand that. You're a twat.
So
I bag next question, please.
Yeah, okay, go ahead, Brent, because it's just hilarious dealing with this guy.
Said something intelligent.
Okay. I'm just going to share my screen, Ranty, just to share a photograph, okay?
Yeah, sure, fire away.
Thank you.
Stupid, Ranty. You really are very, very stupid.
Right.
I'm just having fun with you, Rumpus. This is hilarious.
Okay, I'm making yourself look stupid. Okay, that's fine.
No, not at all. You're the one that claimed it was a photon.
Rumpus, can you see the photograph I have on screen?
Yep.
It's from one of Ranty's. It's from Ranty's one for observation. Yeah, Barra Finesse. Now, if Ranty went to the top, back from the crest of that hill, let's say 100 feet back, and he went up there twice a week for 6 months, how often would Barrow and Finesse be loomed up over that hill?
Sorry, the observers at the top of the hill.
Yeah.
So
Ranty's at the top of the hill, but he's back from the crest of it by 100 foot. And he twice a week for 6 months goes and takes observations there with his P1000.
Right.
How often will he capture Barrow and Finesse looming above the crest of that hill?
That below this cliff thing, right? Below this hill.
Yeah.
Well, I don't think you'd ever see it.
Well, how is looming possible then, Rumpus? Because that's an actual geometric quest up there.
What?
And in your side's response to the 275 mile award-winning photograph by Mark Brett was that it was looming that caused the mountain, all the mountain range of the Alps to be loomed up.
Right, but Brian, do you understand that would require a very, very tight radius, very small radius curve to get from the top?
It's not about the radius, Ron. It's not about the radius.
Hold on.
It's not about the radius. There's a lot of other things there.
No. Let me just. It is exactly about the radius. That's what this curvature diagram that I.
The radius is supposedly already there with the radius of the Earth.
Hold on. No, you're not understanding. Let me just. If I could just.
Our crest was at 2,800.
Hold on.
Okay, eight. Was it 800?
Right. Hold on.
It's a ridiculous height anyway in the Pyrenees.
Here we go, Brian. Do you understand?
Yeah, it was at 2,805 or something. 5 meters high in the Pyrenees. And he supposedly had the whole of the Alps and all the land and water between it loomed up in his photograph of 275 miles away. And you're telling me Ranty over a 6 month period would not be able to see Barrow and Finesse loomed up over that hill?
Yeah, correct. You wouldn't, because look, Brian. Do you understand?
How many things would he see loomed up over that hill?
Let me just finish my.
No, how many things would he see loomed up over that hill, Rumpus? But that's not the height of the Pyrenees Mountains.
Well, do you understand that to see?
I do understand. I don't need any explanation.
No, you don't. No, well, I'm going to explain to you.
Hold on.
I don't know the geometry, Brian.
One second.
Look, you know, I get a chance to say anything.
One second. If you're standing on that hill,
I'm trying to give you a response.
What is in your distance from that hill? If you're
Brian, you've asked a question. Let me respond.
What is your distance?
Yeah, Brian, I'm going to try to respond here, Brian. Yeah, Brian, I'm trying to give a response. To do what you're suggesting, which is would require.
It's impossible.
Oh my God! You shut up.
And what you're suggesting is absolutely impossible.
Brian, would you please get out of full-blown
75 miles?
Brian, why are you over-talking?
He's a troll. He's a troll.
Brian, why can't you conduct yourself in an adult manner? Let me give you an answer, and then you respond.
And the whole of the
Brian, just stop string. Let me answer, and then you get another go.
Okay, one at a time. I have to insist. I have to insist now. One at a time. Come on.
Yeah, Brian's at such.
Maybe it could be Brian, because Rumpus has done nothing but talk and prove what a buffoon he is. So maybe Brian could have a go.
Adam, you're being a crackhead.
Right. Okay. Let's qualify. Let's qualify the point. So, Brian, could you qualify exactly what your question is? And Rumpus, listen, please. Don't interrupt. Let him qualify his question.
Okay.
My question is that if Ranty for 6 months, for twice a week for 6 months, stood 100 feet back from the crest of that hill, how often would all the things down below that hill, the height of that hill, be loomed up above the crest of that, the geometric crest of that hill, for Ranty to capture it in his camera?
Okay.
Because Mark Brett, right, took a photograph from the Pyrenees Mountains, right, and he photographed the Alps 275 miles away, right, and the response from your side was that all the ocean, all the land, and the Alps were loomed up.
Okay.
All you said was the word refraction.
Just let him finish, Rumpus.
What effect of refraction? You didn't state anything else. So if you're telling me Ranty would not be able to see anything from the top of that hill loomed up above, any objects loomed up above the top of that hill, right, over a 6 month period, then how could Mark Brett have the Alps loomed up?
That's all he ever does.
Yeah, you've just
shuts up.
Okay, yeah, we get the question, Brian. We get it. Right. Okay, Rumpus, go ahead.
What a moron! Right, to do what Brian suggests, you would need an incredibly tight curvature. So, for instance, here you can see this K is equal to 16. To do what? So you can imagine if Ranty was here, this laser is, and you can imagine this in front of him is the mountain that was in the picture, and down here is where Baron Finesse is. You would need an incredibly tight curvature of the light ray, and that's just never going to happen. You only get these sorts of tight curvatures when you've got something like a hot road or really, really unusual conditions. You just don't get it. Even this condition here, where the curvature of the ray is what's called K.
Don't interrupt.
When the K is equal to 1, which follows the surface of the Earth. So, for instance, to follow the surface of the Earth, you could, in theory, go see as far as you liked with K is equal to 1. But in fact, the radius of the curve, that means it's going up what's called a circulating ray, which means you can see, effectively, there's no horizon. You can see all the way around the Earth.
Don't interrupt. Please don't interrupt.
That's our issue.
Right, nearly finished. But the sort of curvature that Brian is asking for would require something that's even tighter than this K is equal to 16, so they would just never happen.
Okay, so can I just respond then? In that case, what you've just said then is essentially we can't see any looming over any distance up to around about 20 miles.
No, I didn't say that at all.
Essentially, you did.
No, I didn't know you didn't. That's because you're stupid and didn't understand what I said.
No, I understood the question and I understood your answer.
No, you're stupid, Rant. You didn't understand.
You basically were saying that because it was over a great distance, this 200-mile. Wait a minute.
I can explain now because you didn't understand.
Oh, now you can explain. We all heard it, Rumpus.
Because you're stupid. So here we go. This curve here of 0.14. If you were up at a reasonable altitude, that would curve so you could see an enormous distance, even with a curve of standard refraction. Now, as it gets tighter and tighter, say the 0.33 or the 0.5, that would mean you'd be able to see, you'd only need a little bit of elevation and pointing down, and you could see well beyond the geometric horizon. You would just need something in this area here. So with looming, normal standard looming, you get a 0.14. If you doubled that with sort of unusually warm bend, say some of the conditions that Ranty has had at the Barrow Furness thing, Ranty's actually had stuff I think is about around the 0.83 range. He was almost able to see shore to shore, which would involve a curvature very close to 1 here, something like this curvature here. So Ranty has got it, but to do that, you've usually got to get very, very low. But you don't need to have that to see a long, long way. I mean, I'd have to work out the exact maths for the distance that Brian is interested in, this long distance one, but I suspect you would only need curvature of about the 0.33 to do that.
Rumpus, okay. Now, you're saying that he wouldn't be able to see Barrow and Furness loomed up above the geometric crest of that hill. That's what you're saying, right?
2 times.
Now, but how come he can see Barrow and Furness loomed up over the supposed geometric horizon from a 1-foot observation?
Because the curvature required of the light is much, much, much less than the thing you're asking for.
Is it? Right then, this is for Ranty. Ranty, if you're looking out from the top of that hill, are you looking south?
North.
At the top of the hill? North. You're looking north. And what would be, if you stood at the top of that hill, what would you see in the distance? What would be the most obvious thing that you would see that you wouldn't see if you step back from the crest? Let's say at a distance, would it be a city?
I don't know. I've never looked for something that I've never seen, so I couldn't say.
Yeah, but what I mean is that if you were standing at the top of that hill and you were looking north, what would be there along the coast or whatever? What would be there?
Just Barrow Furness, essentially.
Yeah, but after Barrow Furness, what's the next? Would it be like Manchester, or I don't know that?
Oh right, no. Well, it'd be heading up towards the lakes. It'd be heading up towards St. Bees.
Yeah, but there'd be stuff you could see. There'd be stuff you would see from the crest of that mountain that would be observable.
Well, what I can tell you is that I've filmed those buildings, that area, for 2.5 years, and I've never once seen anything loomed up from behind something that I've never seen before.
You have some great globe Earth pictures, Randy.
Never, ever. In fact, there's a lighthouse there, and I only ever see the chimney pots of the house because it's behind a sandbank. And do you know something?
Behind the curve.
It's behind a sandbank, and it's behind a sandbank.
Which is behind the curve.
No, it's behind a sandbank.
But the sandbank is behind the curve.
No, the sandbank is not. Anyway, I have never seen the rooftop of that house. I've always just seen the chimney pots. Never ever have I seen the roof. Right? There's no looming.
I thought you might be interested in a to scale diagram of the observation that Anthony did.
I'm not finished.
Okay, well, really quick one.
No,
this might help you, Brian. This might help.
I don't need help.
You do need help. You need lots of help.
Don't need help.
But there's a really quick 10-second thing here.
Contradicting
hold on. You've had quite a long chat. Brian, you've had quite a long chat.
Brian, you've got a degree, haven't you?
Right.
I left school before I was 15.
Well, I was just wondering, right, whether I was listening to the Rumpus, and I was just reflecting back on his response when he challenged me, and I just genuinely wonder whether you've got what you claim you have, Rumpus, because.
Okay, you can wonder what you like.
Right. Well, no, I'm just wondering if you could actually, if it's ever been proven that you say you've got this physics degree.
I can demonstrate it with the way I'm telling you things.
No.
I'm not interested in this.
That was my whole point. Your response when you challenged me, when I gave you the question back, wasn't that of a degree-educated person. Certainly not somebody that claims to be or purports to be educated in physics. It was a very stuttered response where you challenged me. I gave you the response and. I gave you a question back, and you didn't.
I didn't hear what question back.
I know you. I know you probably didn't understand. That's my point.
What question? What question
exactly? You see.
I didn't hear you. Okay, never mind. Right. So Here we
Probably
go.
went above your head, proving my point that
I heard
genuinely,
that.
Rumpus, is there any proof of this claim that you have this degree?
Adam, can
Out
you
of
finish?
interest,
I'm
mate.
talking. I'm just trying to make a quick
I've
point.
put mine on the table.
Yeah. No,
this
you haven't.
degree you have.
No, we haven't.
What university was it from?
I'm not going to tell you.
I know you because you haven't got one, have you?
Yeah, okay, fine.
You're a faker.
So here we go. So this at
You're an
Brian
absolute
is to
charlatan,
scale.
No, he said it before. It's MSU University.
MSU. I believe that. Right, absolutely believe that. But in reality,
Right,
I think
here we go.
what we're seeing over the past few visits to Rump,
Adam, can you take your
the demise and
somewhere
undoing
else,
of somebody that.
So Brian, what I'm trying to show you here is the scale of what the Earth and the refraction that goes over it.
Completely contradicted yourself.
Yeah.
Can you see
You
this
completely
blue?
contradicted yourself, Rumpus. Because the most important thing that I said was from a 1 foot observation, right? So by saying from a 1 foot observation, by saying, well, he can't see it because the curve is not too much. That contradicts my point concerning the Mark Brett photo and the fact that any observations taken from a higher elevation shown a long distance away, like the one to the Isle of Man and other places, any of those, any of those according to your logic,
Brian, it's my turn, and I would like to finish my point, and then you can come back to me about your 1 foot observation. I was just
Rumpus.
Oh,
what was your final year dissertation in Rumpus?
Brian,
in your fantasy degree.
Brian,
what did you do in your dissertation?
Adam, I know you don't like being
quickly. You can do this in 5, 4, 3, 2, 1. Unless you're a liar. 5.
You're a moron. So Brian, what I was trying to point out.
4.
I was trying to point out
3, 2, 1.
The scale diagram of the curve of the Earth.
What did you do your dissertation on, by the way, the Rumpus?
Oh, he just did undergrad. He didn't do a grad.
Oh, you didn't do your dissertation?
Yes. What are you talking about?
You didn't do your dissertation, right? Okay. See, that means I'm more qualified than you actually, because I have a full honours degree.
Yes, so have I. Anyways.
Oh, so you did do a dissertation? What was the title called?
It was on the properties of deflecting things in a magnetic field.
Deflecting things. Yeah, I can believe that.
God, this
I can believe that.
30 years ago now, so I can't remember exactly what it was. Anyway, so here we have a scale diagram.
Why don't you pull that file up? We want to see that one, Rob.
I'm sure
pull that
So
PDF.
here we have a scale diagram of the curvature of the Earth and refraction across it, and you can see here, Brian, that the refraction of this beam of light is so small that it's not surprising we can see long ways across distances. It doesn't require a very tight curve at all to see a long way across the surface of the Earth. So that's why we can see a long way with only minimal
275 miles is not just a small bit.
This is 50
of
miles.
Your globe.
This is across 50 miles. This is a scale diagram across 50 miles. Carry on.
Rumpus, you contradicted yourself completely.
How did I contradict myself?
Contradicted yourself completely because Ranty's the angle of view from a 1 foot observation, right?
You're breaking up. I didn't hear you. You broke up. I didn't hear you.
Ranty's 1 foot observation, okay, it's a very, very tight angle of view, right? Yet he was able to see 13 miles away to the sand dunes, which are 35 feet high, and 18 miles to the Barrow and Furnace, right? And he was able to see all of the buildings in Barrow and Furnace and have a mirage above it, right? So he actually saw that. Now, the point, well, besides the fact that you can't get a mirage from Looming, right? Besides that, what you're saying is that you're claiming Ranty's 1 foot observation to be Looming, right? Because you said it's not that much of a curve. That's what you're saying. Now, from a high elevation, me looking or Ranty looking at a long distance and seeing something at a long distance, right, from a high elevation to another high elevation, that's not much of a curve either.
But Brian, Ranty's observation was across 20 miles. So this, for instance, this curve I've got on screen is 50 miles. So he, in effect, was, if you imagine a halfway along here, so about here is where Baron Furness was, and this is where Ranty was. That's the curvature of the Earth in that situation. You can see that the curve required, the refraction required. Hold on, Brian, let me just finish. Nearly there. The refraction required. Brian, let me finish my goddamn sentence. The curve required. Oh, Brian, shut up. Brian, let me get a goddamn sentence out, you twat. So the curve required to get from here to here does not. Oh, shut up, you twat. Does not need to be very tight at all. The curve you're talking about from that cliff face will be incredibly tight in comparison.
Second now, I'll just share this.
Jesus Christ. Why can't you take turns?
He's just a troll.
Yeah, you're a troll. Why can't you take turns in conversation, Brian?
He can't. I've talked to him for hours, and he can't allow a single word to come out of somebody else without him talking. Not once in hours has Brian ever allowed anybody else to talk but himself.
We just found out the Earth is flat. Let us be happy. Why aren't you happy?
The Earth isn't flat, you idiot.
Yeah, I'm going to show you this one.
Let us be happy.
I'm going to show you this one, Rumpus. Here is a 1 foot observation. Ranty's 1 foot observation.
But you know this is 20 miles away, don't you?
This is
Where's the bottoms of those buildings, Brian?
They're behind other things. They're visually occulted.
They're behind the curve, aren't they?
Behind the curve.
No, they're visually occulted, Brenda. If you listen, I'll have a breakdown.
Where are they? Where's the bottom of the curve? Where's the bottom of the buildings?
And to listen, I'll tell you all about it. The red line here, right? I'm going to zoom in a bit. The red line here, right? There is here. That's the sand dune here, right? The bottom of the sand dune. The red line here is where the geometric horizon should be for Ranty's 1 foot observation.
Hold on. How do you know?
Here in the Mirage is where the refraction starts.
Hold on. How do you know that's where the geometric horizon is? How have you worked that out?
Due to the height of the building. That's what a geometric horizon should be from a 1 foot observation.
What?
That's
from the height of the building? What the hell are you talking about?
Oh, what? Say that again.
What are you talking about?
From the height of the observation plus the elevation of the building. He's put those two things together and been able to plot on this image essentially
no,
where
that's not it either. No, that's not the geometric horizon.
Utter twat. You don't know what the geometric horizon is, do you? You do not understand.
All right, where is the geometric horizon in this image? Where is it in this image? Where is it in this image? Where is it in this image?
Utter moron.
Where's the geometric horizon in this image, Rumpus?
Well, I'd need to do some calcs on that. It's not something you can just pick out of the air like this.
What's that up there, Rumpus? What's that, Brendan Rumpus? What's that up here?
I suppose.
I'll zoom in more. What's that above the yellow line?
God knows.
What's that?
I have no idea what you're.
That's refraction, Rumpus. You can't have refraction from refraction. You can't get refraction from looming. This red line is where the geometric horizon should have been. Ranty should only have seen that much from over observation. Ranty should only be seeing that much of the buildings, which is the top part.
You've no understanding at all of what you're looking. You don't even understand what geometric horizon is. You just
hang on, don't just say he doesn't know. Answer the question.
Hang on. Yeah, answer the question.
What question?
Don't just say he doesn't know. He's asking you the question. He's literally spelling it out in detail for you. He's saying.
What's the question?
He's saying. He's saying. All right, go ahead. You tell him.
I'll say it again, but every time I try to say it, Rumpus and Brenda keeps talking over me.
Oh no!
I don't do that.
Be quiet.
God, it's annoying, isn't it?
But I don't talk over you, Brian. I would never do that. I would never treat you the way you treat other people.
Yeah, exactly.
Why would I do that?
You can take it, you can't give it. You can't give it, and you can't take it, can you?
That's just reaction from the TV.
So you give it, and you can't take it. So should we ever talk to you like you do to everybody, Brian? Should we just keep on over-talking you?
If you leave me give you the question.
So what are you talking about, Brian? What's the question?
Be quiet, I'll tell you.
Can you answer the question, please?
Yeah, I know this is really a devastating point for you guys. And it really is a devastating point for you guys.
Rumpus, let Brian ask the question. Why are you
Ranty,
why do you talk over him like that?
Brenda, 1 second.
Will you tell us what the question is, Brian?
Yeah, he's gonna detail it now, Brenda.
A chance, and I'll do it. Okay.
Right, go ahead.
I was hoping it would be sooner rather than later. Can it be sometime?
When it comes sooner, the sooner
when do you think it's going to be?
Right, guys, listen. I'm gonna put you on mute if you carry on, and I'll just explain what it is to the audience. So.
Well, you never put anybody else on mute.
The whole panel, not just you. But listen, I'll let him ask the question.
Yeah, go on, Brian, ask a question.
Okay. This photograph, it's a 1 foot observation. He's seen this, right? This here, that's a 35 foot high sand dune. That's 13 miles away. The buildings are 18 miles away, right? The bottoms of them are occulted by other buildings and the sand dune, because Ranty's at 1 foot. That's actually 30 feet above Ranty's height, focal height. Sorry, this is 34 feet above Ranty's focal height, this sand dune here. This red line is where the geometric horizon should be if we were on a globe, right? This yellow line, right, hang on, I'm not finished. This yellow line, right, is where the refraction starts, right? You can see it's refraction. It inverts the whole thing up into the sky. So all Ranty should be seeing if we were on a globe is between this red line and yellow line, right? Now, the problem is, this is a 1 foot observation. There is no geometric horizon in this anywhere, right? There should be an horizon 1.23 miles away from Ranty, not there. Okay, I'll just.
I don't accept any of the facts that you presented there.
You don't know what
it's a horrible photograph.
And there is refraction in it, but the refraction is shown here as everything is inverted.
Right, Brian, what you're showing us there.
So you don't have geometric horizon, and you have refraction.
Right, Brian.
So
Brian,
where are you You're telling me that this is possible to be looming, even without a geometric.
I'll explain to you. Give me a chance, Brian. Right. A, you don't know what a geometric horizon is. B, you don't know where to position it. D, is hold on. I'm answering it. And you can't see a geometric horizon, as I've explained earlier, about 2 hours ago. You only see the apparent horizon. You can't see a geometric horizon because light is bent. Hold on.
That's a good question, Rumpus. So where does 7 over 6?
I'll answer your question in a second, Adam. I'll answer your question in a second. Let me just.
That water looks flat to me.
So why are you interrupting him now?
Exactly. You're a twat, aren't you, Adam? You just cannot conduct yourself like an adult. Right, Brian.
What are you talking about?
Get the opportunity to actually speak.
Okay, I'll accept your question, Adam. I'm happy to answer questions.
Continuous
right.
dialogue.
Oh,
so
Jesus
I was just asking.
You're not just shut up while I'm answering Brian. Take your turn. Take your turn, Adam. You seem incapable of taking your turn. You're a twat. You're socially inept. You can't behave like an adult.
You have no. Even though you talk.
I am answering Brian's question at the moment. We're answering Brian's question at the moment, you twat. We're answering Brian's question, and then you get a chance, and you can ask a question then. Let me answer Brian's first. Brian got the question first. Brian asked his question first. I'd like to answer Brian's question before yours, and then you can ask your question.
Right, guys, I'm going to round up in around about 5 or 10 minutes at most. I'm just taking them off because they're just battling each other, and it's just turning into a bit of a shit show whilst they argue with one another. But essentially, Brian brings up an excellent point, going back to my image, which is essentially you can't have the whole image being refracted up and then have the refraction turning it into a looming event, which would invert the building of Barrow on top of itself. So you can't have that. You can't have those two effects. So it's either got to be one or the other. It's either got to be a very flat surface on a very flat, calm day, which is what I've always said it was, or you've got to have some weird things going on, refraction and looming at the same time in the same image. Totally preposterous.
I'm trying to answer Brian's question, but I've got this twat interrupting me.
It's the top line, isn't it?
Interrupting me.
I am.
They've changed the image, Ranty, haven't they?
Yes, I have.
Because this one has got a lot less clear area where you have to define this 7 over 6 meeting the 6 over 6, which is why they changed it, mate. It's a joke.
So, yeah. 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 So, no. So no, it's 30 feet. There's 30 feet. There's 30 feet of obstruction at least on the farthest platform, and about 15 on the near one. So no, it's not true. What you're saying is not true. This is
guys,
completely refuting the flat Earth. It's not possible.
Guys, this is the white swan.
No, this is
the white swan.
No, this is your black swan. This refutes flat Earth.
Yeah,
no, it doesn't.
It is your black swan, Ranty.
No, it doesn't.
Your black swan.
Brenda, do you agree that
it doesn't refute. It
Brenda,
doesn't.
Ranty's already just absolutely knocked you out the park.
No, he didn't.
Real-time data.
No, he didn't.
That just absolutely destroys you, doesn't
Brenda,
it?
it would only disprove it if this happened all the time.
Absolutely.
So was the camera underwater?
Well, all right, Brenda. Look at the image.
Was the camera underwater? You said the swell was 2 feet. You said the swell was 2 feet. He put it.
Yeah, my mistake, guys. The audience didn't get to hear my absolute devastating point. And my devastating point was this. And I'm just going to put you guys on mute whilst I repeat it. So the devastating point was very simple. That on this day, Travis took it on the 30th of the 1st. I went to the location at 11 a.m., which is when he took the image. Checked the swell report. The swell report was for between 3 and 4 feet height of swell, which gives an amplitude of 1.5 to 2 feet. That means that his camera, being set up to just 1 feet at the shoreline, would have had to have been looking over the waves. Those waves would have been a physical obstruction due to the nature of the swell. Just the swell, not including the wind-driven waves, just the swell alone would already be high. He would have to look over the swell of the height of those waves, and they would cause the obstruction that you are seeing right now. It's very, very simple.
So you're saying that his camera was under the water?
No, Brenda.
It was below the swell? Was the camera below the swell?
Below the amplitude of the swell wave, yes, Brenda.
So the camera was under the water?
No.
Ranty, I think you probably need to explain to Brenda the concept of what swell does. How
was the camera underwater or not?
No,
was the camera underwater?
No.
Well, he said the camera was at 1 foot. The swell is at 3 feet. So the camera was underwater, right?
No. Explain to her, because she clearly doesn't understand how this effect plays out in real world. But
yeah,
you're so maybe
called graphic occultation. The swell height is higher than Travis's center lens.
Let me just address this.
Is the camera above the water or is it below the water?
Let me address this, please, guys. The question is
the camera above it or below it?
Brenda, your question is, show us some science that explains how this picture. So science is the cause of an effect, isn't it, through an experiment. And we can demonstrate that waves cause the effect of obstruction at the bottom.
Yeah, but
that's what we can see.
The camera was placed above the waves, wasn't it?
No, not the waves.
Yes,
not the waves.
It is.
Brenda, the waves in the foreground are bigger than the little tiny pinprick on the horizon. That's in the massive background.
So they won't. So the waves on the horizon will never obstruct your view.
Do you understand what the swell is, Brenda?
But the waves in the background are tiny, and they could never.
No,
obstruct
Brenda,
your
this
view.
is why I'm asking.
Because they would never be taller. They would never be taller than your observer position.
So you think that the swell is always below the camera line?
Where did he place the camera? Above the water, right?
No, not above the swell. Below the swell.
Not above the water? Waves. It wasn't above the water?
I'm going to share my screen now, Brenda, and you can have a look at what swell actually does. Right. So you can see my screen now.
I just want to say this is just diversion from Brenda. This is all diversion.
Yeah. You understand this type of image, Brenda. Yeah, you understand this side-on view, right? Hold on, don't interrupt me. You didn't like it when people interrupt you. So I'm just explaining this to Brenda, right? This is a typical image of how you would expect to see swell. On any diagram, you can go out and find these. It's not hard. If your camera is at 1 foot down here, let's put your 1 foot camera on the shoreline there. And then what you have is you have this swell area here. So let me put another line in. And we're going to This is the amplitude of
camera.
Wait on, Brenda. Hold on, Brenda. Hold on, Brenda.
Just asking.
So I've put a line in there, which is if the water was at rest, that is how flat the water would be. It would be flat and level if the water was at rest. But because it has a bit of swell on it, it has a trough and it has a peak.
Yeah.
So from the trough to the peak, you're talking 4 feet, right? And this is the swell, so it can be up to anywhere from 4 seconds in length between there and there to up to 25 seconds from there to there in the length of it, right? So from his position on the shoreline, with him setting his camera up at 1 foot, and he's now trying to look over at this wind turbine over here, he's having to look over the wave. He's having to look over it because there is obstruction.
He's not having to. That's the point.
Yes,
he's not having to look over the waves.
The wave,
because the camera is placed above the waves.
No, it's at the shoreline,
yes,
Brenda.
It is.
Brenda,
it's above the waves. There's no amount of swelling that will make it obscure the camera.
Really?
Because the camera is above the waves.
Okay.
As long as it's above the waves, unless you're going to say he put it under the waves, in which case it would be in the water, wouldn't it?
Okay, just one second.
Just quick question, Ranty.
Hang on, wait, no, 1 second. 1 second.
Quick question.
So let me bring this image across. So do you see these surfers over here? Do you see this wave? See this wave here? Obviously the person on the shoreline's taken this image.
Yeah.
You see all these,
sure.
You see this wave here? Would you say that wave is higher than the person at the shoreline?
In this illustration, yes.
That's swell, Brenda.
That's a wave.
The camera is
well done.
That's not swell.
That's
a wave.
That is what happens with
That's not swell.
That is what happens with the breakers, the swell.
But the camera is above the waves.
Well, you're right, Rumpus, because waves will sit on top of the swell and have another effect.
Yeah, exactly. But the camera is above
magnifying the effect even more. So, yeah, good point, Rumpus.
Here's
the camera
image.
is above the waves, and so there is
no
way that would ever obscure the camera as long as the camera is above the waves.
The surf zone.
Wave amplitude.
Wave heights. Crashing. Hello, Brenda.
Well, yes, if you're below the waves,
you're never.
Yes,
you're below the wave at the shoreline. Your feet at the shoreline are below the swell height amplitude.
Yes. If the waves are higher than you are, then yes, they will obscure your vision of the horizon.
So if he's if he put his camera at 1 foot and the swell is at 4 feet, which means there's 2 feet of amplitude on that wave, how is he not looking over the wave?
Because he placed the camera above the waves.
At the shoreline, but the shoreline is not. The shoreline is not where you account for swell, Brenda.
Are you claiming the swell doesn't increase the water height at the shoreline, Ranty? Are you saying that swells do not increase the
he thinks that there's a bulge. He thinks that there's a literal bulge.
What I'm saying is,
Ranty, can I just ask my question? Quick question.
Sure.
Does a swell lift up the water level on the shoreline?
Does the swell lift up the water level on the shoreline? Barely. Inches.
But surely, if you just quoted that wave that you just saw, with all those surface on it, when that comes
no, Brenda said that there's no waves that can obstruct you can cause obstruction looking at. And I just showed that there was.
Francie, when that wave that you said was swell comes into the shore, it's going to come quite a long way up to the shore, isn't it? So that's effectively going to raise where the perceived
it all depends on the topography of where the land is. That energy can stop long before it gets there. So that's just incorrect. That's incorrect thinking.
So you don't think that the swell increases the shoreline water level?
No, I said that if it was a very, very sharp, something like this at the shoreline, and that was the thing, then it would break, and of course it would cause things to go higher. But if the shoreline is very flat coming in
can you switch back to the picture that I'm sharing?
No, I want you to focus on this.
Right. So
because here is the water. I can't talk to you both at the same time.
Right, but with a shallow
I cannot talk to you both at the same time.
Just a really quick one. So you're saying with a shallow beach, the swell would not increase the water level. Is that correct?
Barely. Inches.
Okay, let's go and have a look at that.
So what we have...
Switch to Could you switch
No,
to
let
the
me finish.
photograph I'm
Let me
sharing?
finish this point. The image that you put up on the day that it was taken, Travis took that image and he had to look above the height of the waves,
That's
and that's
fine.
just a
That's
simple fact of the story. It's an end
I
of
accept
story.
that.
Right.
I accept that.
Right.
Could
Good.
you switch to the photograph that I'm sharing?
I will.
Am I still sharing it?
Let me just stop sharing now. You may need to reshare now.
There we go. That
Yep.
should be coming through. Is that coming through?
Yep.
Okay. How
Mhm.
high are those waves?
I have no idea how high those waves are. You tell
Do they
me.
look like? Do those waves? You can see the waves, the little dark streaks.
Hang on 1 second.
Do they look like they're They're large enough to obstruct your view?
I need to give a shout out to Travis, who's actually here. Do you want me to bring him in? The plain truth. Ask Brenda how the 30 foot was derived. Where did that value come from? That is his question. That's his
I got that.
$4.99.
Yeah, I got that from Blue Marble Science. He said that the level of the platform about halfway is 15 foot. So I'm guessing that 30 foot would be the floor of the platform without the pylons, right? So I'm guessing that about 15 feet is obstructed in the close platform and more than 30 feet in the far platform, and that's my guess.
So as he looks
the
over
question
so I'm answering it now. So as he looks over the swell, he is literally being forced, due to perspective, to look into the wave. If he wanted to look at the bottom of those of that distant oil rig, as it turned out, there was a wave in the foreground, just probably a few hundred meters away from him. A few hundred meters away from him, there was some swell that was a foot higher than his camera, and over the greater distance of up to 9.5 miles, that would have accounted for what you saw in that observation.
Ranty.
That's a great picture, Ranty. Who's
Ranty. Excuse me.
I think that's Tony.
No.
That's brilliant. Even a child.
Excuse me.
Yeah, look at that image. Look at that image, Brenda. Look at that image, Brenda.
With the golf ball,
Look at that image. Look at the image.
Look at that.
Look at the image on screen, Brenda.
Excuse me.
Can't see below his knees.
Excuse me.
Even a child.
Where's his knees gone? Are they beyond the curve?
Not comprehend the implications of that.
Look at the tiny houses in the background.
Excuse me. Allow me to talk.
He's a giant.
No, it's okay. I was
Excuse me. That's the
horizon. No, I won't. It's fine.
That's the horizon.
Yeah, you asked me.
That's not a wave.
And I said no.
That's not a wave. That's the horizon. That's the horizon. You can see the horizon.
No, you can't.
That's not a wave.
No.
Can you?
Horizon.
No, you can't. Can you prove that? Because I can prove that there was swell higher than his camera. I can prove there was swell higher than his camera. Can you prove that was the horizon?
That's the horizon because that's
I can prove that there was swell higher than his camera.
That's where the sky meets the ocean.
I
that's
can
the
prove
definition of a horizon.
I can prove that there was swell higher than his camera. Can you prove that was the horizon? The geometric horizon.
What is the
was
definition?
Oh, wait a minute. Yeah, you're right. So was it the geometric horizon, though, Brenda, or was it a wave giving the appearance of a horizon?
No. What's the definition of a horizon?
Was it?
Not sure any position
That's
to ask.
the
Was
horizon,
it the
Frankie.
geometric horizon? Was it the geometric horizon?
That's the horizon.
Was it the geometric horizon,
There's only
Brenda?
one horizon, Ranty. You taught me that.
No, I'm asking you the question.
There's only one horizon.
Was it
Ranty.
the geometric?
There's only one
Was
horizon.
it the geometric? Just answer the
You
question.
got your knickers
No, but
in
there's
a twist,
only one.
Brenda.
Was it the geometric
That's the
horizon,
horizon.
Brenda?
Yeah.
There's only one.
Was it
That's
the
the
geometric
horizon.
horizon?
That's the horizon.
Was it? Answer the question, Brenda. Was it the
I
geometric
don't know
horizon?
What the geometric horizon.
So
is
why are
in
you
this-
claiming that there was 30 feet missing then?
This is.
So why are
the
you claiming
horizon.
that there was 30 feet missing then?
Because you can't see it.
And what's your explanation for that?
It's obscured by the horizon.
And what? So at that distance, coincidentally, 30 feet essentially would be missing if it was a geometric horizon, Brenda. So you're claiming it was the geometric horizon, yeah?
It could be.
No,
It's just
it can't
horizon.
be. Do you know why? Because
Why
the
can't it?
swell,
Why can't
the
it be?
swell was higher than his camera. Bingo, game over.
If the swell is higher than his camera,
boom! You just got
if the
owned.
swell is higher than his camera, how can we see the platforms at all?
Let me just have a minute here. Let me just change the perspective slightly.
How can we see the platforms
Admit it,
at all
Brenda.
if the swell is higher than the camera?
Rumpus. Are you there, Rumpus? Rumpus? I don't think he's there, is he? Perhaps Brenda could answer in his absence. Brenda.
I am here, sorry. I am here.
Ah, great. Rumpus. You know the light that's coming from the platform? You know, because Brenda says that it's obstructed by Earth curve.
Yeah.
If the Earth was flat and light curves down because of the density gradient, as you say,
yeah,
the bottom of the platform could curve into the water before it gets to the sensor of the camera, could it not?
Yeah, but you'll see the light that was going up slightly. This is the problem that Ranty had whenever I last had a hangout. He doesn't seem to understand that light does not necessarily leave horizontally. You could have light that goes slightly up from the platform, and then it would arrive at the observer.
So, answer my question directly. If the light from the bottom of the platform that appears to be obscured by Earth curve didn't actually meet the sensor and it curved into the water, say 10, 20, 30 feet in front of the sensor, because it didn't actually get to the camera, we would then perceive, because we're not getting the light from the bottom of the platform, we would perceive that the platform would be behind the Earth curve, but actually it's just light that hasn't made it to the camera.
Yeah, but the point is, the light leaves any point on the... hold on, let me answer... Please answer. Let me answer your question. The light leaves a point on the oil wrap platform at all angles, so there would be an angle that it would be able to get to you. But it'd have to go slightly up. So yes, you're completely correct that light is bent down. So that means that the light you are seeing from, say, the platform that you think is horizontal has actually had to go slightly up to begin with, because it then bend down to you.
But that would work the other way around then as well when it appears to be flat, because when you say that it's all being loomed up, then that would also mean that the light that's not being loomed, because it's like it's traveling on a different path, that would also come into the thing, and that would again give you the perception that the Earth is flat, because it's a different ray. It's a different path. Well, if you're saying that the light that's following on a different path...
Can I show you a diagram? It's better if we've got a diagram.
No, don't just answer it in... You don't have to diagram it.
You do, because...
You don't have to go back to that, because it's like you're just going back to it.
Otherwise, there's a confusion about what everybody means, and it's always, I've found, always advantageous to refer to a diagram. And
no, in your mathematics...
No, it's not mathematics, it's a diagram.
I just want to say, though, in your mathematics, on a flat plane, you should always see everything. Correct. Even though you're taking into account this atmospheric deviation that is causing the light to bend down, right? Even in your case, in your model, it will strike the ocean, but you can't have it on a flat plane.
I can't have what on a flat plane?
Yeah,
that's effect.
That's the double speak. That's the double speak. Yeah.
That same effect.
Right. Look. Right. So here. So let's go to a flat Earth model. In fact, let's go to the flat Earth model that we did for Anthony's observation. Oh, don't seize up on me, for Christ's sake.
Rumpus, did you understand this point? Why cannot rays attenuate and not make it to the observer?
Attenuation is a separate issue. Well, because if we can see things at the top of an object, that means they haven't been attenuated. Therefore, if we can see things at the top, we should see things at the bottom.
Let's say there's an instance where the rays are curving down and like aggressively.
You said attenuation.
No, but let's add that on top of it.
Hello.
Let's add that on top of that. Let's say they're curving downwards and they're getting exhausted. They're getting attenuated.
Well, then in which case, then you'd lose the top of the ray light as well, wouldn't you?
No, not why?
Yes, you would, because if it's attenuation, then it would affect the light coming from the top as much as it would from the bottom. Idiot.
Rumpus, I have a question for you.
I'm just finishing. Let me just answer Anthony's question. I was going to show him the flat Earth scenario he was describing. I'll try and explain what that's going on.
Is this your own flat Earth model, not ours?
No, the only flat part of it is the flatness. So here we go. Let me show you the.
Yeah, but I'm talking about the path of light.
Yes, so am I.
If you're saying that a different ray on a different trajectory gets, if you're saying that a different ray on a different trajectory does get to your eye, I'm going to say, how can you prove that? Because light travels in straight lines and not on exponential immediate curves at all distances and angles.
Right, here we go.
Displayed. It all deviates from straight, not following a curve.
Right, so here is the flat Earth.
Hey, Riley, don't say light travels in straight lines, so their eyes will. It'll test your mathematical knowledge and end up looking like a retard.
I mean, if you like, you can think of Anthony's question here. Now, we've got the Isle of Man observation here on a flat Earth. So
just got to ignore it, and you rumpus.
I'll answer any question you've got, Adam.
But you still haven't answered my retort.
I mean, do you behave like this in real life, where you interrupt the conversations, then demand attention like a small child? I will answer your question, Adam. Remember what your question is, and I'm in the middle of answering Anthony's, and then I'll deal with you. What's the problem?
So Rumpus, no problem. But just 1 second. From a high level, do you understand?
Evening, Travis. By the way, mate.
Right. Can I answer Anthony's question?
No, I was just saying good evening to Travis, Rumpus.
Right. Yeah, you're a twat. Okay, Anthony.
So poor manners. Travis is arrived.
I'm sorry.
I'm
chewing with my mouth.
Right. So Anthony.
I'm talking with my mouth full.
Right. So Anthony.
Hello.
Right, Anthony. Now, here we've got your observation of the Isle of Man. So we've used the temperature conditions that you had on your first observation, the one in the
temperature conditions that I had. Well, you've guessed.
No, we worked them. No, we went and found them out from meteorological data. Right.
Okay.
So we actually went and got we got 4 different temperature heights for those the 2017 observation you did with where you talked about the floating.
Here comes the ray tracing bullshit. The bullshit stew. That's what I'm going to call it. Bullshit stew. Apparently this can only work on a globe. Can't have a flat. You can't have the rays falling into the ocean on a flat plane. That can only happen on a globe. No. You can only have refraction of light bending down, on a globe. You can't have it on a flat plane. But that isn't what he demonstrated in his presentation, and that's why I held him to account. Didn't have to try very hard. He incriminated himself. And now he's going to try and double down. Here we go.
Get to the observer. So his basic point was, oh look, all these light rays wouldn't get to you, so it seems as though it's good. But the point is that the light rays slightly going up that would reach the observer. So although you might not have a straight line, the light ray that came horizontally from the thing, but you can get hold of the light rays from it that actually curve slightly up and then are bent down. So no, Anthony, that would not account for obstruction. You would be able to see the platform.
Rumpus, do you think you made any sense there whatsoever?
Well, I appreciate for you.
No, I understood his point. To be fair, I understood his point.
There you go. Anthony, I'm going to give you that. I think you are brighter than Adam, actually.
No, but the problem is
incredible.
But explaining it
in
and
many ways,
demonstrating
Anthony is
true.
I would not distract from Anthony. Is a very, very intelligent man.
No, there you're wrong. I'm afraid.
Significantly more than you, both in intellect and obviously real life qualifications.
You're not qualified to have an opinion because you're too stupid.
He's more qualified.
It's very good of you to point that out. Very good of you.
Listen,
have you finished? Right. So Anthony,
your explanation makes logical sense, and I agree. It's explained. It can be proven to be true.
Well, it just follows physics, basic physics. I mean, I can.
Not basic physics. There's no physics for this. Light doesn't follow a curved path.
Yes, it does. Okay. I'm going to demote you now. I mean, yes, you've just made that statement that actually points out you are in fact very stupid.
Wow, bloody hell. Aaron Morfeld, thank you very much. Ranty, cheers with a big fist. Thank you very much. $50 super chat. Absolutely amazing. Thank you. Don't know what to say, but yeah, thanks very much.
Okay, let me just.
No one believes that.
Okay, man, don't mind. I'll answer your question, but first of all, Adam claims I've contradicted myself. What have I contradicted myself about?
If you don't know, then you're even more.
Okay, forget it then. Okay, you don't answer the question. So, Monica, what's the question?
These surface rays, like how do these light rays have a desire to curve over the surface of the Earth? Like, help us understand.
Light waves don't have desires, moron.
Why do they bend down? Is that the question?
No, you're
no,
saying
he wants to know why they have desires.
You're saying that there's instances where these light rays curve perfectly over the surface of the Earth, that K value of 1, right?
Okay, the K value of 1. Okay, let's go to that. That's quite an interesting case.
Do light waves have desires, mind of God?
According to you guys, it does, yeah.
No, they don't.
Naturally.
No, light waves don't have desires.
Well, here we're talking about a constant medium, and then
do they have desires? Do they have desires?
But Brenda, those rays of K1
do light waves have desires?
Just if you wait 5 seconds, you're going to see somebody claim that it does.
Yeah, he's saying
light waves have.
No, he's saying no, Brenda. He's saying that we think it has. That's what he's claiming.
Exactly.
No, we don't. Nobody thinks that. Nobody thinks that light waves have desires.
Check this out. If you go on mute for a few seconds, you're going to hear it right now. Check it out.
Right.
Let's go.
So your question to me is, as I understand it, correct me if I'm wrong, is why does light ever follow exactly with this k is equal to 1?
Exactly.
Why does it follow the surface of the Earth exactly in this k is equal to 1?
And it's traveling through a constant medium, correct?
Correct. Well, sorry. So when you say constant medium, this medium is non-homogeneous. In other words, it's
but it's that ray. Let's say that ray was driving in a car. It's driving through a constant medium when it's going along the surface of the Earth, correct?
Yes, but that's because the gradient, as I explained to Adam earlier when
we're not. No. But now you can't weasel out of this. There's no gradient. It's right along the surface.
There is. That if you understood differential. The gradient that comes. Let me show you the circumstances that bring that about. Here we go. I've got a diagram here with the.
But wait, Rumpus, just to fast forward the argument because I think I get your point.
Here we go.
One second.
So here's a diagram of the gradient.
No. Let me word it to you just so for the viewers who maybe don't follow this the physics. You're saying it's constantly going to be up against an interface that is lower density. It's going to constantly want to guide itself towards the Earth, right? That's your
correct
high level. Okay, that's preposterous, man.
No,
that's insane.
That's what the laser in the tank I showed earlier was all about. That's what it does.
It's almost your argument is that literally this light has a ceiling above it, and it's constantly touching the ceiling and re-navigating down, and then touching the ceiling again, and then pushing itself down, touching the ceiling. No one's going to believe that.
No, you don't understand refraction. Look, how do you explain this?
It's worse than that, isn't it, Rumpus? Your explanation is significantly worse than that. There isn't
we're talking about the surface ray. Don't
would allow you to do that.
Don't bring up
a
this
magical differential.
Don't bring up this green thing. Go back.
Always is the correct
k-value of 1
to allow this bend.
I would like to answer mind of God's
Adam, one second. Right, so, don't bring up this green thing. Go back to the k-value.
No. I want to because it demonstrates the point. I've got a visual evidence here for you to see and understand.
But promise me you're going to bring me. Promise me you're going to bring me back to that k-value of 1.
But okay, do you understand that if the gradient in this tank was steeper, that this curve would be even greater, and it would curve more and more and more until eventually you could get almost any curve you want. So the point is. Your question was, does it hit a ceiling? Well, you can see when it reaches when it's horizontal here. I think I.
Rumpus, that's 1 second. Go back. Scroll up a bit.
Put another beam of light in.
Rumpus,
would it be
see
at
that
the same
ceiling?
observer point?
See that ceiling? You're going to need a new ceiling at the end of that ray, right? To push it, to get it to continually steer down, right? See that green right at the end on the interface? You're going to need a new ceiling to push that thing constantly to keep it curving.
Yeah,
right?
it's called leapfrogging. It leapfrogs.
You can check Skype.
Leapfrogging laser beams.
Yeah, do you agree with that? That's the issue. We don't. That's not real, man.
Yes, it is. You can see it. That's
no. But let's say we were. How would we continue that? What would be needed for that ray to continue to travel in a concentric direction?
Just a temperature gradient. That's all you need.
Right. So, but draw it on that, or show us on the other diagram what exactly will allow the ray to do that.
I'm going to show you this. Sorry, I've lost track of my bloody.
Dude, just can you open up? I can't believe I'm even asking. Can you open up a new paint and just draw the ray and then show us what's happening?
Hold on.
Guide that ray.
I want to just show you why the light bends. I seem to have lost track of my bloody thing. Hold on.
How many pages is this effing file, man?
Number.
Yeah, you need to trim this down, mate.
No, well, our point is it's designed for people just to search through it to find the bit they're into. Here we go. To find the bit they're interested in. Right.
So it's not designed for presentations, then. Thank you.
Not really, no.
It's gonna break the internet, man. Just slow. Don't go so fast.
Right. So the point is, you're basically asking me why does things follow a particular radius? So just imagine this can be almost any curvature I could have here by increasing the gradient. In other words, making it more dense here and less dense up here. If I could arrange the gradient.
No, I only care about the surface ray.
Yeah. Okay.
Equals 1.
Right, but you don't seem to I mean, it's.
No, you can give me the background. Give me the background if you need to. That's fine.
Right. Okay. But the surface ray. This is a surface. You can think of this. Imagine that this. If this was the Earth, imagine underneath here, then this could be a surface ray if you really wanted to do that. So I could say, if I imagine this was I
This
could now.
can't be the Earth example, Rumpus, because it's flat and then it's deflecting. We get the part that it can change direction. We give you that. That's not what we're arguing.
So
that's not the shape of the Earth, man. It's not flat and then curves.
But if you understand that,
so hang on, can we get this right? You want to have a look at? Do you want to have a look at the part in the left corner of this ray?
Is that the issue?
The mind of God. Yeah.
Right. So, left or the right. Yeah, either one. Exactly. I want.
Go to the left-hand side there, Rumpus, in that box.
Both of them.
Right. So in fact, okay, let me just move that.
What's going to motivate the left to start curving or the right to continue to curve, whiwhichever one you want to attack?
Well, this basic refraction. I mean, look, if
just go to that left one there. Yeah, just zoom right in on that.
Yeah. So it begins to curve down here. You see, so it's there. There it reaches the top. It reaches the horizon where it's moving horizontally, and then it's still deflected down. So it goes. Even though it was horizontal at this point here, it will actually begin to carry on curving down and form, and it will carry on getting steeper and steeper. So because the rule is, with refraction, it'll always deflect towards the denser gradient. So here, when it's at this end, it's going up, but it was deflected down. So it's always deflected down. When it gets to hit, it's deflected down. Although it's still going up, it's changed its angle a little bit to be more downward. So it's more downward, downward. More downward, more downward, more downward, and it carries on being more downward. That's the rule. It's becoming more down. Although it's still pointing up at the earlier points, it's becoming more and more and more and more and more downward until eventually here it becomes horizontal, and then now it's actually pointing down, and it will carry on increasing.
We have no issues with that, but you agree that it's starting flat, right? The ray starts like you said.
Yeah, okay. Imagine this ray here then. Okay, imagine this ray here. Imagine this ray here. It's where at this point in the imagine this is coming out of a laser. So if imagine I created my laser here, and out popping from the left-hand side was the green, was the laser coming out horizontally, and it would do. So this is exactly the same scenario if I were to put a laser here and then fire a beam out horizontally, as it is in this diagram.
Our issue
on a flat plane that would happen.
Yeah, you're using layered strata that are flat, so you need to show us how a curved, I guess, that medium curve will give us that result. That's why are you using our?
Yeah, it's a flat tank. It's a flat tank.
Flat tank. That's right.
Correct. With flat layers.
Why are you doing that?
Correct.
That doesn't make sense, man.
But what you've shown here, let me just say, is absolutely great because we've got flat layers and we've got a flat laser shining the light out, and the light bends down.
Correct.
Right, which is what we see.
No different.
Perfect.
The diagram I showed.
Doesn't need a curve. Doesn't need a curve.
Yes, but it wouldn't curve as much.
Doesn't need a globe. Doesn't need a globe.
If this was wrapped around a ball, show us how the light ray is motivated to stay along the surface. That doesn't make sense, man. Like, help us.
It just so happens to be the same curvature. I mean, if you've just accepted that light rays bend.
Well, we don't want to just accept it. We want proof.
No, we accept it in this layered flat strata. We accept it when it's layered and flat like this.
Right.
Yes.
Well, that's exactly what happens on
No, but wrap it around a ball and then show us how the surface ray is motivated to travel.
Do you not understand that? Right, from that laser tank we were just at. John, I go back there. Oh my God, where was I? Got it here.
Rumpus, how much money would we have to raise as flat earthers for you to burn that file that you're scrolling through right now?
It'd have to be quite a lot. It's worth quite a lot.
I'd put $50.
It's worth much more than that.
No, but we group do it. But I just put that out
there. The lol value alone's worth $50.
Yeah, it isn't worth spit.
You're too stupid to appreciate it, I'm afraid.
I donate negative $50. You pay us to burn it.
Rumpus, you could just put it online and get Brenda to delete it without.
Right. So you accept here.
Shout out to Adam Meakin. Right, Shout out to Adam Meakin.
Mind of God, you accept. You accept that we've got a curve.
Shout out to Crow.
So if you had these layers were curved as well, it would curve more. And there would be a certain concentration that we could put in the tank where this radius of this curve would match the radius.
No, but that statement you just made, I don't agree with, where you said if you curve it, it's going to curve more. No, that's not a technical statement.
Because it would no longer hit the this light here would no longer come in near horizontally. See, if I tipped these layers, if I made them spherical layers.
Yes, that's what we'd like to see.
It would actually cause. So in other words, if I were to create, instead of having these layers horizontally, I created layers that looked more like this. So let me just make.
Dude, you're claiming that straight, flat strata create curve, and we have no issues with that. We're worried about curved strata creating curve rays. That doesn't make sense, because you're showing us right here, flat strata create curve rays. We're comfy with that. Now, the magic trick is coming where you're going to curve that strata and then say that the rays also curve. We don't like that. So just help us.
It's called refraction.
Yeah, Brenda, just let him do it if you don't want.
No, it's called refraction, though. That's what it is.
So
it's a concept that you don't understand.
Yeah, and he's going to explain it to us.
Yeah. So
well, you're still not going to understand it. It's a waste of his time. It's a waste of Rumpus's time.
So if I've got these.
This right here is light bending down on a flat plane. What you have is the density gradients. You have the light emanating straight out, but deviating downwards, heading towards the denser medium. This is essentially it, guys. It's all there. Rumpus's own diagram. You don't need to presuppose a globe. The light just leaves the object and it starts to go down. Bottom up obstruction on a flat plane. Just using A, Fermat's principle, and B, refraction, that just bends the light down. Sure, the whole image will drop, but you'll lose data because most of it won't get to the observer. It will fall and crash down before it even gets there. Bottom up obstruction on a flat plane.
Tipped over, and that means that if you follow the Snell's rule, it will actually cause an increase in the bending. So I mean, that's what. Anyway, but the point is, there is some particular.
Were you just joking on your lies?
Nearly finished.
That was a lie. Right?
None of those lines.
Nearly finished.
Image you're using.
Nearly finished.
Rumpus, your body is telling you the answer that it's flat.
Nearly finished.
Keep going.
Nearly finished.
Cool.
Come
so
on.
What that means is there's a
could need a Heimlich maneuver by the end of this.
There's a particular level of the gradient here that would cause this to match.
He's an ether band maneuver.
That would cause the bend to match.
Could you tell me again, because I literally stepped away for a second. I missed the first part of this presentation.
I don't understand why you're bothering to
do this again? Just tell us again.
They're not listening to you. They're not listening to you at all.
I am.
No, I am. I genuinely want to listen. I want to listen.
You're not. No, you're not.
I stepped away for a minute, and I missed this part.
I've got to go to bed anyway. Right, so here we go. If I were to make these layers this shape instead of the flat shape, that would mean that the light would become the angle of the layers, with the gradient concentration. So if I just put it in here, would go like this and like this.
All those layers uniform in the same gradient differential. At the same rate.
So that means this is where the gradient now be.
I understand the point you're making. Are those gradient changes exactly even from 1 centimeter to the next?
They are in this diagram.
At the same in the diagram, but are they in reality?
Why does that matter? Why does that matter?
Oh, Brenda, don't be so dumb. I ain't
but why does it matter?
You're going to be so stupid.
Why does it matter?
Because that diagram isn't reality, Brenda. That's not real.
Why does it matter?
Brenda,
because
don't
it's
dumb
not
it down.
reality, Brenda.
Why does it matter?
Shit.
Because it's not reality, Brenda.
Just let him finish the point.
Could I finish answering my question? Randy asked me a question, as Brian de God did as well, and I'd just like to say, so that when you've now got the gradients, and that means
flam rumpus. You're not answering my point. I'm
answering Randy's previous
the differential.
Point. I will answer your point after I've answered Ranty's point.
Or is it subject
you don't seem to understand the concept of taking turns. I'm answering Mind of God and Ranty's point. And then I'll answer your point. And then I will answer your point.
Smooth, continuous change, even
rate of... Could we just let him do his, dig his own grave here?
Right.
In my own words.
Adam, you checkmated him earlier with the 2x, man. We're
right,
good.
So here we go. So if we had gradients like this, it would actually curve more because the Snell's law, we've altered the angle here on this diagram for Snell's laws. We've altered the angle of the medium boundary in effect, which means you'll get additional curvature. But the point is that there is a certain gradient here that we can do that we can change it to mean that this laser beam would follow the curvature that I've just shown you here. There's a particular value of the gradient that would cause this laser beam to exactly follow it. It's a very
Rumpus, you believe the surface, you know the lowest channel that you made, the lowest one? You believe that light rays are following through that, right? Along in that K value of 1 situation? You believe that there's rays that are only going to go through that lowest
particular value of the gradient, density gradient caused by a particular temperature gradient.
But help us understand what the gradient, the relevance of that in the bottom layer that's constant density. You curve the density profile, right?
Yes.
That lowest block, the bottom 2 black lines, okay. The bottom one, the lowest one, down, that channel, I call it a channel because that's the way I think of it.
So it's a layer.
Medium. Yeah, right. It's
so
constant medium, right?
I mean, obviously, this infinitely small, so I've drawn it as one layer.
Yeah, fair enough. Yes, yeah, fine.
So but the point is, there is a particular value of the gradient, how dense the change, how steep the density gradient is that would cause light to exactly match. Now, obviously, you can have slightly more and slightly less, but that does happen in the atmosphere as well.
No, but help us understand why does the gradient matter in the calculations for those rays along the surface? I understand that it's relevant to do the math, but what relevance does that have when those rays are only going through the lowest channel, that small thin sliver you made?
But that's because
are the rays bumping up against the top and hitting it and then constantly driving around the curve? Help us understand.
No. It's to do with the second differential of the gradient in actual fact, but it means that it can go constantly through the same layer and maintain the curvature.
Yeah, that's what Riley, I'm not trying to speak for him, but none of us like that, man. That doesn't. Yeah,
I'm afraid that's what reality is.
But you can't just say that's what reality is.
I can show you. I'll tell you on another occasion. I'll go into the math for you to show you how that can happen.
That is what reality is not.
Correct.
Right. Correct. Anyway, I think I've exhausted my patience, and I think I need to go to bed.
Rumpus, I thought you were 24/7 with this ballers, man. How are you?
Not at all. Just occasionally I get excited and do something, but no, most of the time I don't. Not at all. Absolutely not.
Those light rays traveling along the surface.
Before you go.
You're not going to run away when this is getting really tricky for you, are you?
Not tricky at all.
There's no trickiness going on.
Came up earlier.
It's trivially easy to demonstrate the stupidity of the people opposed to me.
Rumpus, everybody's demonstrating that your mathematics is incorrect, and you're not coming back with sufficient review.
You haven't shown a single point of that, Adam. You haven't shown that.
Yeah, Brenda, we've gone to what's called an extreme case in the limit.
And when you interrupted, you demonstrated your ignorance.
What are you talking about? What are you talking about?
I don't need to go there.
I don't know what you're talking about.
I know you don't.
What is it you're talking about?
Just another huge thank you to Aaron for hitting the super chat, and good servant as well. Thank you very much for smashing the super chat as well. Much appreciated. I really do. Thank you.
Right, I'm just about to go.
Yeah, what is
that? Wanted to ask me something before I went.
One last question, Rumpus.
Yeah,
remember Brenda showed that photograph earlier from Travis's observation.
Yeah.
And Ranty stated that on research that the swell height was a couple of feet higher than it would be possible for Travis's center lens to be.
Yeah.
Yeah. Do you accept then that is the explanation for that? Not that it matters because we have the Black Swan. But
I don't. No, I don't.
I don't accept that the swell height was higher than the camera.
Every time a flat earther has told me their height above the surface of the water, they've always got it wrong. So, for instance, Anthony claimed he was only 1 foot high.
Hang on.
Anthony lied.
Brian, can I just finish my bloody sentence?
No, Brian won't let you do that.
Right,
Brian, just so you're clear, everybody's a liar. Otherwise, it doesn't fit in with Rumpus's.
Well, we know we've caught them in lies.
Otherwise, everybody has to be a liar.
Every single person.
Not everybody. Just flat earthers are.
Brenda, chill out.
Every single time someone like Bradley or Anthony has claimed a particular observation height, they've been shown to be wrong. So I bet you that Plain Truth has not put this
that's just a blatant lie there.
Quick, I'm right here, Rumpus. I'm right here. Okay. Right now,
So how?
Hold on,
Rumpus.
Quiet, please, Rumpus. Hold on, I'm nearly there.
Okay.
Ranty, if you want to just simply check your Skype, I just sent you a shot of the wet, high tide, inundated sand where I set my camera down as quickly as I could to get the shot.
Did you turn your camera around so
did you put it in this chat, or did you put it in?
It's in Skype. It's in Skype to you, your personal Skype.
Plain truth, have you got, in your video of this thing, have you turned the camera around 90 degrees so we can see where the tripod is and how you are in relation to the
I'm not on a tripod, Rumpus. I went down to the ground, Rumpus.
So you knelt down or you crouched down?
I set the camera
on
the ground.
Okay. You actually set it on the ground. Okay.
Yeah.
And how far away was that from the edge of the water then?
You can see it as soon as Ranty pulls up the image.
Yeah, are you sure you sent it me? I've not got it. It's not
well, I'm at the beach right now camping, and I'm going on my phone's hotspot, so it might be delayed.
Oh my god.
On Jose's
So can
showed
the flat
video.
earthers explain this
Second,
picture?
Brenda, I'm speaking.
You know what, Brenda? Let me ask you a question again, okay? Where did the 30 feet get derived?
I got that from Blue Marble Science.
Yeah,
That
how
was
did
his
he
figure.
get it, Brenda? How did he get it?
By calculating the curvature and the position and all that stuff.
Yeah,
and
yeah.
also from photographs.
Do you have that
of the
documentation,
platforms.
Brenda? Brenda,
That's
do you have
on
that
his channel.
documentation?
It's on his channel.
Brenda, do you have that documentation?
It's on his channel.
Okay, why don't you produce that and show us the documentation for that?
Yeah, it's a video on his channel. Just go look it up yourself.
1 second. I saw Jose post this video of Travis's, right? I watched a little bit of Jose's, and he posted a video, and you can see the water lapping, literally almost hitting the lens. I thought at one point it actually hit Travis's lens. That's how close
I was
he
afraid
is.
for my life, Brian. I feared for my life.
Yeah, it was that close. It actually looked like there was a big wave coming in at him because he was so close to the tiny little water that was lapping, almost hitting the center lens. I can actually show you proof that exact thing, besides even using the black swan, right? It does this here, all these observations that the globe shows, with this water here lying above the lower end of the frame, is impossible on the globe, because everything at a distance drops below center frame. So that, if we're on a globe, should be below center frame or at the very bottom.
But you could dip down your centre frame, you idiot. You're not keeping it horizontal.
That doesn't make any difference, the rumpus. Right, listen.
Of course it does. If you point down...
Doesn't make any difference. Right.
Yes, it makes difference.
No, it doesn't. You've obviously never used a camera.
That doesn't change the centre of frame.
Right.
You utter idiot, Ranty. You utter moron.
Doesn't change what you're seeing and what you're not seeing. Right, listen.
They tried to run that little game on us too, man. That didn't work, man.
Yeah, listen.
Yeah,
I want to do a mic.
I
want to do a mic check.
Observation.
I want to do a mic check.
Every supposed globe proof.
So Ryan, can you say hello there, Ryan? Because you've just joined.
I did. Is it working, Ranty?
Yeah, you're coming through good. You said that you can put this to rest within a couple of minutes.
I can.
Okay, good stuff.
I can actually.
Go ahead.
Brenda, what is the truth to you?
Oh my God, I'm off.
What the hell?
It's a very simple question. What is the truth to you? What does that mean?
It means that a statement is true when it corresponds to reality.
Okay, so I'm going to ask you a question now, and I want you to answer truthfully, okay, to the best of your ability. Right? Are unicorns real?
No, they're not.
Okay. Now, when I prove that you're wrong and that you don't know what truth is, okay, are you going to accept that these guys have been telling you the truth the whole time, that the Earth is flat?
Yeah.
Okay. So what I want anybody to do who's ever got the stream here, okay, I want you to look up a one-horned rhinoceros, okay? The scientific name for this animal is called Rhinoceros unicornis, or unicorn. This is where that word originates from.
That's
okay?
false.
It's
not true.
It's fact.
No, the word unicorn. The word unicorn the word unicorn came before that.
Look it up.
And the
It has
unicorn.
everything to do with it. It has everything to do with it because what you guys are explaining to everyone is the truth, correct? But they're not understanding the truth. Okay, so when they hear it, they think of a lie. Just like when I said the word unicorn, he thought of a horse with a horn instead of the actual truth of what is factual reality, which is a one-horned rhinoceros, which is where the word originates from.
No, it's not where the word originates from. The word comes from before that. No, the word predates the naming. The word predates the naming of the rhinoceros.
Okay, then you show that.
Were you listening, dude? What, man? Were you listening to the whole hangout, man? We were talking about optics and stuff, man. What's that? What does this have to do with?
Well, he's got his very, very third grade epistemology he wants to work out.
You're missing the point. It's like a game of telephone where one person says this to the next person, right? And the message gets mixed up along the way.
Shout out to Treble for the truth. Good servant. I do this for you. Thank you for the £2 super chat. Very much appreciated.
No offense, man, but that has nothing to do with this, man. Like, no offense. Like, nothing. Like, not even close. Like, not even close to close.
So the only thing that I brought up, okay, is the fact about truth that you do not understand what actual truth is, okay? So if you can look up and put it on the screen, it'll take 5 minutes. It's only going to take 5 minutes, and I'll get off of here. But you can look it up. Rhinoceros unicornis. You can Google it. It's a fact. Okay? That's where the word originates from.
No, it's not.
You can say it's not all you want, but you've yet to look it up.
Dude, are you looking for like some kind of moment where you like catch somebody in a philosophical corner, man? Because that's not the spirit of this
this is not philosophical. This is factual reality and truth. It's like if I told you if your car had a problem, right? And I said, oh, hey, your blinker fluid needs to be changed. And you're all like, oh, okay, how much is that going to cost me? You have no fucking idea that I'm jerking your chain. There's no such thing as blinker fluid. Right?
Yo, dude, can you like step back from the mic, man? It sounds like it's like in your gut.
Well, apologies. I'm in the garage right now and there's probably an echo.
All right, so what's your take-home message for anybody with this? What are you trying to convey?
You need to actually figure out what the truth is and not just assume.
Dude,
like you're doing.
The word was created in 1611 because they didn't have a word for when they were translating it, the King James. They just made it up.
Right, I
didn't even mention the Bible. Why are you bringing up the Bible? I didn't even say the Bible.
That's when the word was invented. Brian. That's when it was invented.
Stop. Both of you, stop. Brenda is proving your point. The word in the Bible refers to a rhinoceros.
Yeah.
Right.
It does.
Right. Brenda's proving your point.
Okay.
Because 1611, she's got this magical reference to the King James Bible, right? Because when you're taking an original language like Hebrew and Greek, and you don't have words in the English, you smith them, right? You create words. John Wycliffe smithed numerous words for the English language because we didn't have concepts like this. So instead of rhinoceros, it was unicorn. Brenda just proved your point. She didn't even know it.
Brenda, would you share that photograph with me, please? The one you had earlier from Travis's observation. Would you mind in the chat?
You can get it from Blue Marble Science.
Would you just share? You have it. Just share it in the chat.
No, you watch
Brenda,
Blue Marble Science video.
He's asking you for my image, Brenda. The image that I
well, then you can give
shot.
it. Then you can give it. Is that the one that I'm sharing now?
I actually can't because I'm at my hotspot is for shit right now.
All I'm asking you to do is share the image, Brenda. What's the problem? I just want to get the image.
Is it this image?
Yes, please. Just share it in the chat if you wouldn't mind.
I'm not really sure how to do that.
Well, it's being shared now.
Yeah.
On Skype.
I'm looking to download it, but hang on, I'll have to just take a screenshot of it.
Yeah, no worries, Travis.
I took this
we'll see that
from.
image.
I took this from Blue Marble Sciences video. It's a screenshot.
Yeah, and do you know what this is trying to show and what it's trying to portray? It's trying to portray that this is a perfect representation of the globe model. In other words, this is the exact amount of hidden that you would expect.
Yes.
Wait and let me finish my point. That this is the exact amount of hidden that you would expect on a globe, except for the fact that Travis had his camera right on the ground, right at the shoreline, and except for the fact that there was 4-foot swells out to sea, which gave a 2-foot amplitude of physical blockage between himself and the thing he was trying to observe, which would have created a physical blockage, giving this exact image, i.e. a fake position for the fake horizon.
That's the horizon, and the platforms are being obstructed by the horizon.
If this was just a globe with no waves on it, with no waves at all, and this matches, right? What happens when you then calculate the swell and then you realize that you're below the swell? If you was living on a globe, you wouldn't have seen any of the back oil rig at all, because the waves would have been on top of the globe curvature.
Yeah, but you're above the waves.
No, you're not. The swell is
above
the swell amplitude is above your feet at the shoreline.
But you're above that. You're
below it.
You're above. No, you're not.
Piss off, Brenda. You're just being dishonest now. You're being dishonest. Being dishonest. Being dishonest. Enough of that bullshit.
You can't be above it if you're standing on it.
Yeah, I'm sorry, but
a ball, you would be on the side of the ball. It's like a hill. You can be on the hill, but you're on the side of the hill on the ball. That's how a ball works, because there's no bottom to the ball.
Ranty, this hangout is game over for Ball Earth, man. Like, if it wasn't already. Like, they're lost in the sauce, dude.
Yeah, it was a pretty epic failure.
Rumpus doesn't want to show us surface rays. He's getting tired. His shoulder hurts. He's got a cough. All this stuff. Come on.
It was interesting just to hear Brenda there deny their own science, which is about wave amplitudes, etc. Just to deny the fact that the swell would be higher. The amplitude of the swell would be higher than your feet at the shoreline. Demonstrates that they don't even know how their model works.
But Ranty, those are the same two platforms as the Black Swan, right? That she was quoting?
Yes.
Oh my God. So where do they think that went? Like on that other day?
Yeah, exactly.
Like that doesn't make, oh my God. I was hoping that it was an other two, because at least it wouldn't look as ridiculous if it was some other.
No,
picture.
I mean, you look at that image and you straight away, I mean, the first image, the image, the Black Swan image, you can just see how flat that water is, how crisp and shiny it is. There's barely a ripple on it. There's no swell at all. But on that, it's clearly completely different. Clearly, you've got a camera that's below the swell height, and you're having to look over the height of the wave. It doesn't take rocket science. There's something in the way.
Yeah.
And that's going to obstruct it from the bottom up. It
Ranty,
just makes
man,
me.
all I can say, bro, is good hangout. I'm gonna drop, man, but thanks for having me. It was entertaining in the least. So.
Yeah, no worries, man. Anybody want to say anything before we go? Ryan, this was your first time on. Are you flat earther, globe earther?
I'm flat earther. Just wanted to say thanks for having me on, Ranty. I know my comment was a little bit left field, but I was just trying to make a point that they don't even understand what factual truth and reality is.
Ranty, just before you go, don't drop that. I just want to share one. Just give me 2 minutes. I'm just going to share one photo. It's a rough draft. Okay.
Yeah, sure. Yeah.
Yeah, just 1 second.
What I'm playing here, by the way, guys, for the audience, is the Skunk Bay footage. And one thing you'll notice with this Skunk Bay is that the imagery that you see, everything that you can see in this image, is everything that you can see. You never see a human being or a building or a cow or a sheep or anything pop up from beyond the curvature of the earth or from behind something else. So it's not like you see anything. Everything that you see in this image is being manipulated a bit like a kaleidoscope. When you twist a kaleidoscope and you change the image slightly, that's all that's happening with refraction. Nothing's being brought back from beyond the curve, even though it's all over the place, all these imagery. Nothing is being lifted up or loomed, right? There's nothing appearing from beyond the Earth curve. You only see, essentially all you're seeing is Fermat's principle and upward refraction giving you this downward loss, especially on this corner over here where this lighthouse is. It appears as a lighthouse there, and you see that it actually bends down. But yeah, there we go, it's almost disappeared now, but it's not being loomed, it's just being bent down, and then it returns to its normal position when the atmosphere levels out, but nothing is being loomed up. It's just like twisting a kaleidoscope, that's all it is. Right, have you got something to present there?
Yeah, just 1 second. I'm just going to take a quick screenshot of something and I can present it. It's just going to be a rough draft. That's what it is. I'd have to get Travis's video, but...
No worries. So have you got a channel there, Ryan? Or do you just listen in? Hello, Ryan? Can you hear me?
I mainly just hang out in the chats, Ranty. I did post a couple videos a couple days ago, but I'm not a big streamer for different reasons.
Okay, no worries. So, Mind of God has gone. Sleeping Warriors dropped. Yeah. Adam Meakin dropped. Rumpus dropped.
I just share this. It's just a rough draft. I need to get Travis's video to deal with. Just to show how much nonsense that this is. But even this will show it in a second now. I'm going to share, okay?
Yeah, sure.
There's the two horizons matching up.
Mm-hmm.
Now, this one on the right, which is Travis's observation, is slightly higher because it's going up at an angle. To get me to match up the horizons, I have to have it like that. There should be more with the back platform slightly higher and foreground platform slightly lower. So, but if you add that, they'd be equal up. So the horizon is matching exactly in both of them. The horizon point is matching exactly in both of them. So that's not possible on a globe.
That's
the horizon they're showing is impossible on a globe.
Yeah, that's a really interesting photograph. I'm going to take a screenshot of that because I'm going to have I'm going to look at this and see all the anomalies between the two, because there's clear distinctions between the two.
Yeah, even in BLM SB's 69's collection, the one that QE showed, where he showed a different day with this kind of a thing happening, that like Travis got. If you even got that, you probably get a couple of good images, and I reckon you'd match them up very well, because it really shows how can this horizon be a globe horizon, yet the same exact level of the horizon is when it's 10 miles away is exactly the same. Yeah, how can their horizon lift is what I'm saying. Everything should drop below center, should start to drop below center frame as it goes away, as you saw as proof, and it doesn't happen. All their horizons, supposed geometric horizons, are always up in the air. Do you ever notice that? How is that possible? So, just a rough draft, but it definitely is a good finish out of the night.
Mm-hmm.
Right, okay guys, I'm going to round up, so any final words?
I'll leave Ryan go first. Hello Ryan, I'm Brian. How are you doing?
Hi Brian. No, I'm good. I think we pretty much put it to rest, like I said.
Okay, Brian, anything?
Yeah, it was obvious with Rumpus not agreeing to the. That's why I asked him the question about the swell height being higher than the camera, showing visual occultation. It was obvious that he denied that. It was obvious he's denying reality, and Brenda obviously is denying everything she can. So it's like, I think tonight was very, very productive. They might say there's 3 or 4 on 2 or whatever, but at the end of the day, it doesn't matter how many is on either side. If one side has the truth, then they can't be beaten. You're not going to.
Yeah.
And we had the truth. So
Exactly.
Okay, guys. Right, so I'm going to round up. Thanks everyone for stopping by. Thanks for everybody who smashed the super chat. Very, very much appreciated. I think I thanked everybody, so I don't think there was anybody missed. I gave some new moderators out tonight, so look after your wrench. That's about it, really. I hope you all enjoyed it, and I'll see you all in the next one.